Hi, Prakash sir.
Hi.
Shall we start? I think
Yeah, we should start, sir. I don't know
joined.
the way. Yeah.
So, hi, good morning, everyone. From Chipin team, myself, Prince Annie. So, on behalf of Chipin team, I welcome you again to this day 3 of 3-day pre-event webinar session on digital design flow by Coral team as a part of Digital Design Hackathon 2025, hosted by Chipin Center, CDAC, Bangalore. So these webinars will provide you essential guidance for upcoming Digital Design Hackathon 2025 starting from 15th of March of this month. So I would like to thank Coral team for accepting our invitation for this 3-day webinar. From Coral team, today we have Prakash sir joined online. So he will be the speaker for today's webinar. So on behalf of Chipin team, I warmly welcome you, Prakash sir, for today's webinar. I would like to request you, sir, to take over the session. Over to you, sir.
Hi, good morning to all of you. I hope everybody is ready for the session. At least a thumbs up and yes in the chat box will be a boost for an trainer to start. Thank you, Govardhan. Thank you. Thank you to the people who have raised their hand. Okay. Thank you. Thank you. I hope everybody is able to hear my voice and I have shared the screen and my screen is visible to all of you. Okay. If anybody is not able to see the things or not able to hear the voice, please check your settings of the system which you are working on. Okay. That's clearly mentions a lot for us. Right. So, good morning to all and all, and good morning to Prince, Chipin team. Okay, thank you for the session, wonderful opportunity given to us, and it's a great pleasure to have set with work with you and the whole team. I hope these 2 days, most of the people have understood a lot of things. I just want to quickly summarize with if anybody has any doubts. Let's make it very clear. See, it's not that I just start sending you the information and all those things. You have to listen to them, and if anybody has got any questions regarding the other 2 days, which was started with Sankalp, started with Manjunath, then Asha, then again Manjunath, then today it's me, Prakash here. Having to start with some of the important information about how to write an application development code for an SOC based designs, right? So why we are doing this SOC based designs also? That's one thing. Quick questions to all of you. So there are two questions in my requirements right now. Okay, one is anybody has got any doubts regarding the 2 day sessions, and can you quickly summarize what you have learned in these 2 days? And a third one is why we are doing this whole setup webinars for you to understand the concepts. If you answer these four questions, it will be always a good thing for us to go ahead for me, right? So let us be clear. Like let's have more of interaction based sessions. It's not that only we need to just keep on talking over here. If we keep on if you have more interactions, I feel it will be more information will be proceeded to a lot of people who are present in this meeting right now. That's my feeling. Yes, can I get the answers? If you can unmute yourself and answer your questions, or you want to um, have chat box answers, anything is fine for me. So you started with one of the very important tasks, that is an HDL flow. Am I right? Yes. Prince, I hope my voice is audible and my questions are clear.
Yes, sir, your voice is audible. Participants can unmute themselves or they can interact directly, or they can type it in the chat box.
I can see Durga saying yes. So can I get the quick summarize from your end? Yes. Any doubts? Anything? Things are there. Okay, so we started with FPGA flow, right? So a little bit of architecture you have learned and how to write the code in Vivado design flow and uh, how to synthesize, how to simulate, how to do code coverages. I hope it's a lot of people have understood that. Anybody has not understood, please let us know. Hardware debugging. Then we have learned about the Zinc architectures, which is present on the Zinc devices. Okay, the PS and the PL, right? And how to add the IPs, how to create the IPs, right? Anybody has got any doubts till now? Okay. Let's quickly start out with this. Okay. So before proceeding to software development, I just want to go with and our agenda as per our requirements today, right? So today we are going to see about adding our own custom peripheral. Okay, right? So how to add that, how to create custom peripheral. Okay, and then add to the existing system whichever you have created. Okay, then afterwards, we'll start with the software development of, environment and write the software basic applications. That's what is our today's sessions, and I'll be showing you how to do the installations of the tool or what is required for the hackathon also. So please maintain the same version. I don't want everybody to be in different versions. Let us be clearer. As per the link which I have shared with you, it is a uh, 2023.2 if I'm right. Okay, so that version I'm referring to include in your systems. Okay, and when you're installing, what are the steps you need to take care? You can have a look on that. That's also a very important things. Okay, that's what is our today's agenda. Am I clear? Any doubts to me from the people? Yes, at least yes in the chat box or and thumbs up. Okay, Suresh, that's good. Thank you, Abhilash. Thank you, Tarun. Everybody should answer, okay? It's not that only one. Okay. So if you have installed already the older versions, please remove it because a lot of things, features are not present, and whatever we have demonstrated, it's available in this version. That's the reason I'm trying to tell you. Am I clear? Right. Okay. Right. Okay. That's fine. Okay. Okay. Let us start with our today's discussions. Okay. Creating and adding the custom IPs. Okay, right. Let us take this. Right. So, in the 2 days yesterday discussions, you started with the Zinc architecture, and you have learnt about the PSPL communications. So, how many of you remember that? How many of you remember that? Okay. Okay. So, you might have heard about the PSPL communications happens with 9 different ports. That is uh, general purpose ports, AXI general purpose ports, and AXI high performance ports, and AXI ACP port. Am I right? Accelerator coherency port. Right. So let's understand what is this AXI is. AXI is what actually? So anybody? Right. So we'll see about today's sessions on what is that AXI transaction is. Right. What is the AXI4 valid and ready acknowledgement models, AXI transactions models, right? So how to make the protocol and involved the steps involved in creating and packaging IP. Okay. Anybody has understood what is AXI yesterday? Yes, at least in chat box. Right. So what is the AXI actually? AXI, it's a protocol, right? So AXI, it's Advanced Extensible Interconnect, right? There are three types of transactions available: AXI Lite, AXI Full, and AXI Master. I hope most of you have seen it yesterday, right? Have you seen it yesterday or something is not understood? At least one person can unmute yourself and talk to me. Just wanted to maintain that momentum going, right? So in the AXI transactions, we'll have there'll be a master interface, okay, and there'll be a slave interface. Okay. So what is this master interface, slave interface? What it tells about? Right. So there'll be a master interface and there'll be a slave interface. Okay. Right. So this master is one person who has to start the initiation, and the slave is to has to receive the data or send the data. That's his work actually. Okay, right. So in the master interface, there will be having if you're going for a read, right? So there'll be address, read address will be there, right? And there'll be some control whether it has to be read or something will be there required. right? So this address has to initiate. He has to initiate it. Okay, right? And once our address is initiated, then the slave identifies it. Okay, this is for me. Okay, they'll have separate address for each of the peripheral, right? So one master will initiate the address, and slave has to acknowledge it. Okay, now this is my address for me. Okay, and whether we have to do read, right? So read means there will be a data from inside our slave registers, and that data has to go to the master interface. That is the read operations. Okay. In the same way, when I'm going for a write operations, when I'm going for a write operations, here I'll have a master interface and I'll have a slave interface. Okay, right? Again, the same address and control will be initiated by the AXI master. Slave will identify, okay, it's for me. Then afterwards, here when it is coming to a write, right? So data has to flow from master to slave. Whereas in RAID, it was from slave to master. Keep it in mind. Okay. And in the write, what happens is once your writing is completed, the write response channel, the acknowledgement has to go automatically from the slave interface. Am I clear? I hope it's clear to all of you. Anybody has got any doubts?
It's
Anybody?
clear, sir.
It's clear, right? Okay, that's fine. Right? So here in the read, what happens is master will initiate it, slave has to send the data things, okay? And in the write, it will be like master has to initiate, address and control, and slave has to get the data from the master, and he has to send me a response saying that acknowledgement that I have received it. That's what is required for me. Okay. Right? So all the AXI channels, whether it is read or write or something like that way, it will be having something called as valid or ready handshake signals will be there for us. Okay, right? So source will assert this and holds a valid when data is available, right? The destination asserts ready if able to accept the data. Okay, data transferred when valid and ready are one. Okay, if both are high, then the data will be transferred, right? So source sends next data or deasserts valid if it is not required, right? And then destination deasserts ready if no longer able to accept the data for us. Am I clear, guys? Am I clear?
Yes, sir.
Okay, right. So the AXI, whatever we are having it, right? So it will have a valid and ready signals available for us. Okay, right? So each channel, whether you're going for read or write, right? It will have its own valid and ready. Whether you're going for a read, they'll have valid, okay, and valid signal and all these things. Yes. Okay. So any questions till now? Right? You can have a look on this. This is an
Sir, screen have stopped sharing.
how come it is? I don't know. It suddenly got disrupted.
And your voice also break from the this slides. Can you repeat again?
Yeah, I'll repeat it. No problem. My data is these things. Okay. I don't know how come. Is my voice audible now?
Yes, sir.
Right. Okay. Please let me know if my screen is stopped sharing. I don't know what's the reason behind this. Okay. Right. So here you can see this. There is an clock coming in this, right? So here AXI will have a valid or ready handshake acknowledgement always. Okay, that's what I was trying to tell you, right? So each channel, whether it's address, whether it's a data or a response, right? They will have their own valid and ready signals. Okay, right? So this is something like you can see here. Here there is the valid and ready are both high only, the data will get exchanged. Okay, right? So you can see here, this is a valid going and this is a ready going on the last cycle. Okay, and this is always ready. This is always ready kind of thing. Okay, and this is same cycle acknowledgement, it will be there. That's how we can work it out, right? So here we are going to do with inserting the wait states, means until and unless the ready gets inserted, the data will not be exchanged here from us. Okay, am I clear? Am I clear now?
Yes, sir. But sir, whether it's is there is any rule to hide the data like valid signal where only the downside of the clock, or it can be hide the any time between the clock types? Sir.
Okay, so your question is this valid signal should be high at any point of time or on the rising edge of the clock?
Yes, sir.
See here in this case, can you see here the valid is inserted on the middle of the clock, and here it is inserted at the some of the other end of the clock, right?
Yes, sir.
So there will be no like such things like when this valid can be occurring or something, right? So until and unless this valid and ready becomes high, the data will not get exchanged over there, right? So it is, as a user, you should be knowing that where exactly my valid and ready should go high, because if I lose the data, is there any problem? If I don't lose the data, is there any problem? Those two conditions. Am I clear?
Yes, sir.
Right? So the diagram answers your question already, Karthikeyan. Okay, right? So in these three cases, there are address, data, and write response, right? So in this address, no, we'll have read and write separately. So read valid will be there, read ready will be there, write valid will be there, and write ready will be there. The same way for data also, data read valid will be there, and data write ready will be there. Okay. Whereas in response, it will be only write. It will not be having any read operations. So it will be having only the write ready or write valid signals. Am I clear? Right? So when yesterday you might have seen very clearly when you have made the Vivado designs, right? And when you're connecting some of the peripherals, right? So when you're connecting those peripherals, you might have seen this AXI interconnect component. Yes? Yes or no? At least. Good. Okay. Right. So in that AXI interconnect, what is happening is you can have one master and multiple slaves connected over there. Okay, right? So this component is highly configurable and it can act as a pass-through, one master, one slave, conversion, okay, or N to one interconnect or one to N interconnects, N to M master interconnects, N to M interconnects, shared bus structures. So all these things is possible with the help of this interconnect. Yes. Anybody has got any doubts till now? Okay. Just I'm just opening the design to show you that concept. Okay. Just try to maximize it here only. Is it clear? Is it visible? Yes, at least.
Yes, sir.
Yes, sir. Visible. Screen is visible, sir.
Okay. See here, I can make this AXI interconnect. See, when you click on run connection automation, this interconnect block is already inserted by the tool. Okay. But if it is not inserted, I can add the IP. I can add the IP interconnect. I can add it by ourselves, right? So we have multiple interconnects available. AXI stream interconnects, AXI interconnects, interrupt, other things are also there. But this is what is required for us, AXI interconnect. Okay. And this is the properties of this. See how many slave interfaces are required, how many master interfaces are required for you, right? Right. So any questions? Slave interfaces, what is the name you want to use? What is the master interfaces name you want to use it? Right? I can use it. So this is the name given to this fellow. It is going to this peripheral, and this is going to this slave peripherals. Okay. So there is only one slave attached to this from the zinc processing system PS portion. Master XIGP0 is coming to this, and this is creating one slave to multiple masters here. Okay, right, right. So there is little bit limitations in the number of slave interfaces. Okay, right? And there will be limitations in the number of master interfaces also always. Okay, so this depends on how much resources are required and what are the things required here. Okay, am I clear? Am I clear, guys?
Yes, sir.
Okay, right. So this is highly configurable interconnect, right? So it can act as a pass through component or conversion component, n to 1 or 1 to n, right? Or n to m. I can have multiple masters connected over there and connect to the XI interconnect, right? And or n to m interconnect, shared bus structure kind of thing. I can have it. So these things are possible with the help of XI interconnect. Okay, am I clear? Right, right. So AXI4, there are three types of AXI available. I hope it's clear. It's explained to you yesterday. Anybody? Or it is first time listening to this? At least you can unmute yourself and let me know. What are the three types of AXI available? AXI Lite, AXI Full, and AXI Stream. Okay. Have you heard about this or not? Hello. At least you can put your answers in the question in the chat box. Yeah. Yes. At least I can get some answers. Right. Okay. So you are aware of what are the XI types, right? That's one thing. Yes. I hope. But there are some very few responses coming. So if anybody I want it to be full precise. Like everybody should at least put a chat box so that I can feel everybody is awakened. Otherwise, what happens is I will be keep on talking and you will be listening to it. Okay. Right. So there are AXI Lite, AXI Full, or memory map, what we call it as, and there is AXI streaming. Okay, right? So in AXI full, okay, Dinesh, I'm not asking you to understand what the signals involved there. Have you understood the AXI concept or not? That's what my question is. Or else I'll go back and at least explain to you that concepts. Yeah, I'm going there. Okay, can you see this? I'm going to that part. Don't worry about that, Dinesh. Okay. See, it is like why we are asking you to understand this concept of AXI is, right? So it is like you might have heard about microprocessor, micro controllers, right? And different kinds of different processors, right? So in that cases, what happens is the processor connects to its peripherals through a bus architecture. But when it comes to bus architecture, what happens is there will be a limitation of data exchanges and all those things, right? So keeping that in mind, what the people came to a conclusion that okay, let us have some common interfaces so that at least we can have faster data exchanges and it will take less time for us. That's the reason this bus architecture moved into an interconnect kind of things for us. Okay, so ARM has got its own proprietary bus architectures. They're called as AMBA, Advanced Microcontroller Bus Architecture. So they have their own lot of information about this bus architecture. I don't want you to people go and refer that architecture and all, but at least keep a known of this, note of this. There's a bus architecture available from ARM's proprietary things here. Okay, right? It is called as Advanced Microcontroller Bus Architecture because ARM has got different variants of devices available with them, right? So they have an application set of resources, they have real-time set of resources, they have microcontroller based resources available on the processor side with them, right? They have 8-bit, they have 16-bit, they have 32-bit, 64-bit processor controllers, everything is available for us. Okay, so they came to an interconnect kind of thing. It is called as advanced extensible interfaces, right? So APB and AHB are bus architectures. It is called as advanced peripheral bus and it is advanced high-speed bus available. Okay, AHB bus, right? So some of the high-speed peripherals they'll be connected to this AHB and some of the peripherals will be connected to this advanced peripheral bus. Okay, even in our Zinc also this is the same case available. Okay, right? So in AXI, there are three variants available. One is AXI memory map or full. This is the first variant which came to existence. Okay, right? So generally, how this mm, what we call as uh, this architecture came into picture is right. So they will have most of the interconnects will have master and slave interfaces. Okay, so this master and slave interfaces will talk to this peripherals, okay, right? So they will send the address, okay, and they'll have the data exchanges between them, whether it is read or write, right? So if it is a write, then there should be an acknowledgement coming from this slave. That's how it is there, okay? Whereas if what is this data exchanges, whether it is only one data, 8-bit data or 16-bit data or something like that way, or it is multiple packets of data like this. How this is behaved, right? So in the full, there'll be one address, but multiple packets of data. That's why it is called single address, multiple data. and it is called as data burst feature. Okay, right? So this was traditionally used in most of the peripherals, most of the processor-based architectures. Okay, so Xilinx has come out with one small changes in this. Okay, so instead of having multiple datas like this, okay, they came out with only single address and single data. Right, there will be no burst in that cases. Okay, am I clear, guys? Right, and streaming means there will be no address kind of thing in this. No address, no response, nothing. Only data exchanges, and it will be burst always. Okay, am I clear? Yes, I
Yes,
hope
sir.
it's right. So this is how it is worked actually. Okay, right. So AXI signal will have this master interface, slave interface, read address channel, read data channel will be there, write address channel, write data channels will be there, and write response channel will be there for us. Okay, right. So AXL Lite there will be single address, single data. Okay, and so and when we implement them on a FPGA, it takes very less resources. That's why it is called as very small footprint. Okay, right, and it will automatically included with the help of AXI interconnect, whatever is required, that will be included over there. Okay, right. In the same way, address write also will be having address, and write data will be there, and write response will be there for us. Okay, and in sorry, full it will be read data, right? Then there will be multiple packets of data like this. Okay, and the same way write data also will be having multiple address and multiple multiple data will be included. Only address will be single. Okay, single address and multiple data what is required for us. Okay, right, and it can go up to burst up to 256 data bits. That's what is required. Okay, and in streaming there will be no concept of the address and response, and the master will keep on sending the slave whether you want to receive it or not. It's his things. It's his request. Whatever, right? So like video or PCI Express, this kind of interfaces required some sort of streaming data. That's why we use this streaming data channels. Okay, right? Am I clear? Yes. Am I clear now? At least an S will be a good thing for me.
Yes, sir.
Okay. So here, if you can just open up this and see what are the things it is included, right? So there is AXI AW ID, AXI AW address, AW length, AW size, AW burst, AW lock, cache, prod. So many signals are there in this. Okay. So when you're creating your own custom IP, so you need to know like, okay, one thing is what are the things required for you, whether you are going to create one slave interface, whether you're going to create some of the other interfaces, that I should be aware of it, and based on that my signal varies. Okay, that's one thing. If you can just have a look on this. This is about slave side here. Okay, and if I go with master interfaces, there'll be a lot of other interfaces, other signals coming into picture here. Okay, so you'll have ready AW ready, right? Read, write ready, write valid, write data, right? Read valid, read ready, read data. So this kind of signals are very essential for us in our activities. Okay, am I clear? Right. So if you are going with full, right? So they'll have one address, but there'll be multiple data. Okay, right. So here, if you could see this, there is multiple read transactions are identified by the different read ID what is required. Okay, am I clear? There are two reads required here. That's why I'm getting two read address, read ID address. Okay, right. So for if you're going for a burst transactions, only one read ID would have been used. Okay, right. So separate R last will be there for corresponding read transactions. Okay, Am I clear? And this address read size 2 indicates there are 4 bytes are being read. 0 is for 1 byte, 1 is for 2 bytes, and 2 is for 2 bytes. Am I clear?
Yes, sir.
Right? So for the write transactions, right? Write ID, write address, how many bytes of size, and valid and ready, whether it is there or not. Okay. Then what is the data, right? And if there is no a burst, right, then this last also will come into picture. And valid and ready should be always there. Write valid and write ready. Okay. This is for address address write valid, address write ready. Okay. Here in this point, this is for sorry, 1 second. This is for address write valid, address write ready. This is for write write valid and write ready. Okay. Then afterwards there will be response also. For that we use this B. Okay, be valid and be ready for this. Okay, these signals. Okay, so this small signals you should be always understanding it. Okay, because if somebody asks you to create some of the IPs, at least you should know where I could go and understand this concept of what are these signals are about, right? That's one important information I just wanted to give it to you in this session for you. Okay, am I clear? Any doubts to me till now? Right? So multiple write. You're going again, the same IDs will be AW ID will be there. So how many transactions you want to do it, I can do it. Okay, it's not for burst. Okay, it's for something. I want to read it for multiple data sets. Okay, okay, right. So in the status signal, that response okay will come into picture for corresponding right transactions. Okay, and there will be and write strobe 0xf. Okay, this will indicates that entire word is being written. Okay, am I clear? Any doubts to me? Right?
So in the image, why they are using two clocks? Both are same clock or different frequency?
Which one? Which clock?
A clock and B RAM clock.
This is for a BRAM peripheral. That's why I've shown you different angles. Block RAM, it's a portion of an FPGA. I hope it's been explained to you by Sankalp on the first day. Right? What are the components available on my FPGA resources? Okay, right? So if you're going with a block RAM read something, if you have a peripheral in a design like block RAM memory is included, okay, right? So in that places that BRAM clock will be different, okay, and the peripheral can be anything. This is something like this way. I'll just showcase to you, okay. Right, let me add one block RAM memory, VRAM memory. Okay, so if you are using this AXI VRAM controller, right? So what happens to you here is, so this will have one clock. Okay, this is a controller. Okay, so this controller will inherit the block RAM memory of my FPGA, right? So this AXI clock will go to the AXI the block RAM clock of the block RAM memory, and that clock will be fed here. That's the reason. Am I clear? Am I clear?
Yes, sir. That means both will have same frequency.
Possibly.
So, and one more doubt, that A with it's taking two clock or A address, AW address taking two clock pulse.
It depends on the word size. It's the 32-bit word.
Okay.
Okay. And
What
how many
typical word
bits?
size is 32 bits.
Each word is 32-bit.
Okay.
Okay. And this based on your right ID, EW ID is there, right? Right address, right IDs. Okay. So
Yes,
based
sir.
on that, how much clock cycles you are being giving the value for this, right? So based on that, this right address will be fed for that one. Am I clear?
Yes, sir.
Right. So this is the right burst. Okay. So when you are having burst, there will be something called as AW length. Okay. So now your question is answered like this way, right? So there is an address coming here, and there is a right address, right ID is 0 only. Okay. And the length, AW length, the size, the burst, we're going for an increment based address for there. Okay. And the valid and the ready signal will be there for us. Okay. And the data is D0, D1, D2, D3, all these things. Okay, right? Then based on that, my right last and right valid, right ready will be inserted. Okay, and my response will be inserted after this write is completed for me. Okay, and the last indicates the last signal. The last is the right. This signal indicates it's the last of the burst. Okay, right? The same way, this is also for block RAM memory. Am I clear? Yes. Right. So you can refer to this user guide 761 to understand the AXI reference guide. Okay. And you want to learn about AMBA's protocol, you can go to infocenter.om.com, that link. Okay. And there you can go to these topics. Okay. And please use your create an account in the ARM to understand these protocols. So they're not freely available. They'll be available only once you are been registered for the ARM website. Am I clear, guys? Okay. So these are different AXI signals. I have explained a little bit already in my previous sessions over there. Okay. Right. So if you're going with AXI 4, AXI Lite, right? So what are the signals will come into picture? Okay. So AXI 4 and full, that is, and Lite, there'll be one small difference will be there is full will have the burst, whereas Lite will not have the burst. I hope it's clear to all of you, right? So in the full, there'll be global things like clock and reset. Okay, it will be available for both XI4 full and XI Lite. Okay, and there'll be read address write ID, address read address, address write address. This is for writing signal. Okay, then length, size, burst will be there available only in the full, whereas in Lite there'll be no other things. Okay, and valid and ready will be available for both of them. These signals are very essential for us. These signals are to be known to create our own custom peripherals. Okay, right? In the same way, for write data and write response, right? So there will be write data and write strobe. Okay, light will have this write data one and write strobe two. Okay, last will be available only in the full, whereas in light it will not be available. Okay, and the valid ready, the response signals will be available as BID, B response, B user, all these things. Okay, right? So this one indicates 32-bit, two indicates slave can ignore assuming all bytes are valid. Okay, and this three indicates EK OK is not supported here. Only OK is supported in this case. Okay. Right? The same way for read also, there will be different namings, right? As I mentioned you in the initially only, right? So the read valid, the read ready, write valid, write response, write ready. All these things will have different things, different naming conventions, but they act like the same way as I have mentioned in the previous slides. Okay. Okay, but there will be no some signals will not be available in light version because it is not a burst data style. Okay, am I clear? Any questions to me till now? Any questions are there till now? Right. So when you are creating your own IPs, okay, so Sankalp might have explained to you like, okay, I have written my RTL code and I have made it as IP and I can use it as a block diagram or an instance in my RTL code. Yes, I hope it's clear to all of you, that thing in the first day. At least an yes in the chat box will be always a good thing. Right? Good. Okay. So it's not for only some people who are making thumbs up high or something. It's for everybody. Okay. Right. So you might have seen that how to create an IP using an RTL code. But today, what we are seeing is how to create an IP with an AXI wrapper. That's one important aspect for us. Okay. So which I can insert it to my processor-based designs. Okay, right? So generally, when you take up any of the IP creation, right? So in especially in terms of AXI based things, right? So my IP is whether it's a slave or whether it's a an master IP. That makes us very essential for us, right? So whether your IP is slave or whether your IP is master, right? If it is a slave IP, right? If it is a slave IP, right? So, and if it is an light, XI4 light, or if it is an XI4 full, or you're going to create an streaming IP, slave streaming IP, master streaming IP. So it depends on you. I can create those things in using my IP creation wizard. Okay, right? If I take this slave, let us take an example of slave IP, right? Because most of my RTL code, whatever I am trying to put, it will be a slave IP only. It will not be a master. Because if I go with master, then again I have to write a lot of logic involved in that, and it takes more time for us. Okay, right? So, but you can write it. There is no restriction that you can't write it. Okay, but only thing is, it is your responsibility to make the initiation logic required for that. Is your as a user, as a designer, you have to start the creation. Okay, right? So most of us very clearly we are aware of this 5 channel signaling scheme, which I have explained to you already, right? If I'm having a read address, read data. If I'm having a write address, write data, and write response. Okay, right? So in my IP, whatever I'm creating it, right? So this fellow has to be very clear that whether it is an master or whether it's an AXI light or whether it's an AXI 4 full IP is available. Okay, right? So if it is a light IP, right, then this will have this user IP created by you. Okay, and all this transactions logic, whatever is created, the wrapper is going to create us that will be available for us, right? So and all the signals required for me to do the connectivities will be available for me in this wrapper, and I can connect it to the AXI interconnect. Am I clear, guys? Right. Let's move further. Right. So how to create this IP? Okay. I can go to this tools. Okay, in the Vivado. In the Vivado here. Okay. So this tools here, the tools create and package IP. Right. So whether you are going to start with the current project that you have seen already in the previous sessions, but I'm interested to go with this, create a new AXI4 peripheral. Okay. Am I clear? Any doubts to me till now? Right. Okay. Karthikeyan has given, Tarun has given, Durga has given a thumbs up. Govardhan has given thumbs up. Sugesh. Okay, that's good. Anybody else? Right. Right. I can go with create new AXI4 peripheral. Okay. So, sorry. Then once I go for this, right? So whether you want to go with AXI package your current project or package a block design, what you have created in this particular design, or you can create an AXI4 peripheral package a specified directory, you can go with that. Okay. Right. And IP, see one when you're creating this IPs, right? So there are certain standards need to be followed. That is through this IPXA ACT format. Okay, so it's a standard given by the worldwide team. Okay, and we have to follow certain rules for there. Okay, so this IP is an IPXA format. Okay, IP exact what we call it as. Okay, and it will include all the source codes, constraints, test benches, and any documentations you're using in your design, and test benches you're using, the simulation files you are using. So all these things will be included in the IP format. Okay, right? So I'll start with create and package IP wizard. Okay, and I'll start with create new AXI4 peripheral. Okay, right? So here this will, sorry, right? So when you create new AXI4 peripheral, it will create an AXI IP, and whatever the drivers are required, software test applications are required, IP integrator, AXI, VIP simulation, and debug demonstration designs also will be included for us in our designs here. Okay, whether you are going to create an AXI4 Lite, whether you're going to create an AXI4 full, is what is required for you. Am I clear, guys? I hope it's clear. Anybody has got any doubts? Anybody has got any doubts? Any doubts? Anybody has got any doubts? I'm just waiting for the questions. Okay. Right. Okay. Let's have a small tea break. Okay. And we'll be joining back in 11:15 or 11:20. 10 minutes break is fine for us. Is it fine, Chip in team? Hello. Hello. Can you hear my voice or not?
Yes, sir, your voice is audible, sir.
Let's have a break. Okay.
Yeah, sure, sir.
Okay. We'll be back by 11:20 onwards then. Okay.
Yeah, sure, sir.
Hi, good morning. So can we start?
Yeah, sure, sir, sure.
Sure, okay, right, that's fine. Okay, right. So we can create the AXI IP using a template already available in the Vivado. That is, you can go to tools and create uh, and package new IP, and you can select this create new AXI4 peripheral. So this will create automatically the AXI IP and the completely the template for the slave or master peripheral. That can be an AXI lite, AXI full, or AXI stream. Okay, and there'll be and software test applications automatically the drivers required for that it will be created. Okay, and even waveform examples also will be created for that. So bus function models we call test, right? So that is also created and we'll be able to simulate them also. That's also possible. Okay, right? And you can create once you create a custom IP automatically I'll be able to make this add IP to the repository, or you can go to edit IP if you're creating a new peripheral which is not available. Okay, that also I can go it over there. I can create the user logic already available. Okay, and I can create it like that way also. Okay, and I can verify the peripheral using the AXI4 VIP. It's okay, or using a BFM simulation, what we call it as, right? So the bus function model simulation, what is example design required for us. And okay, you want to verify your IP using JTAG interface, that's also is possible. Okay, using this is available for me, right? So when you create the template, right? So if I go with for light, then there'll be registers created like this. They register 0, 1, 2, 3. Okay, and it will be having the width of almost like 32-bit width. Okay, and a user can have lot number of registers, but our minimum required number is minimum is 4. Okay, so without this 4 will not be able to move further, but the minimum number is 4, but I can go extend it a little bit more also if you are required. Okay, and once my whether it's for reading or writing options are required, then I'll be implementing that logic required. It will be available also, right? Whether to read from the registers or write to the registers. Okay, it will be implemented accordingly. Okay, user logic can be easily connected, and user logic can be a hierarchical design also. What do you mean by hierarchy? Okay, I'll have the top level file. Okay, and that top level file I'll be calling inside the logic. Okay, this becomes my hierarchy like this. Okay, so this is my slave IP. Let us take this, and this is my user IP included here, and this is my other logic controlled black box kind of thing, something like that way. Okay, that I can include it. This becomes my hierarchy here, right? So this hierarchy is also maintained in our design variable. Am I clear, guys? I hope it's clear to all of you. Any questions are there? Okay, right? So once your light this user logic is required, right? So this is my AXI AW address. That is the right address. Let us take example of this. Okay, right? And this will have this address of LSB and the memory bits to the address of LSB, the optimum memory address. This all these things. Okay, so this is an if statement included here. Okay, and based on whether how many byte index you are using it, right? So based on that, it will be using this registers write data or read data, whatever is required, it will be available here, right? So this is the data, and this is my registers compared to here for us. Okay, am I clear? Any doubts are there? Any questions are there? I hope my screen is visible. Yes.
Yes, sir, your screen is visible, sir.
Any questions are there?
No,
Team?
sir, no questions in the chat box.
Okay,
Sir,
right.
can you please repeat from the last line?
Okay. From here, ma'am?
Yes, sir.
Okay, right. So I start. We are going to have this in the Vivado here, right? So when I click on create new AXI4 peripheral, I can type this all these things, okay? And which location you want to add it, and what is the version name, what's the display name, all these things. We have a demo, don't worry, right? So there'll be number of registers included. All these things will be created, and once your IP is created, I'll be able to add to the IP to the repository or edit the IP or verify the peripheral using the BFM simulation, or verify the peripheral of the IP using the JTAG interface. That is possible with the help of the custom IP here. Okay, and this IP is going to create what how many interfaces are required, what is the driver, the test app, what is required here. All these things will be created for me in this custom IP. And when we create that template, right? So it will have this information like slave registers will be included. This is what I was showing to you here. Okay, the number of registers 4. This is the minimum is 4, but I can go up to maximum of 512 registers. Okay.
Sir, is this code it is generated by default or we have to write the code?
Now this code is generated by default.
Okay, sir.
This is a template automatically created by the AXI peripheral IP. Whatever created. Yes.
Okay, sir.
Right. So this connectivity, everything will be included. But whereas the user logic will not be automatically generated, it is you have to write the user logic code required for your information. Okay, according to your requirement of IP creation. So based on that, user logic is will be blank. Okay, user logic has to be written by the designer or the user, whatever required. Okay, so when you are generating the template, there will be minimum of 4 registers. I told you. Okay, so this minimum number is 4, but maximum it can go up to 512 in terms of sync. Okay, but it can go a little bit more in the other devices, which I don't want to discuss in these sessions. Okay, right? And code, whatever is required, that will be created by the.
Sir, your screen is not visible.
Yeah, I just got it. So once I get this message, your meeting has been recorded, automatically the screen sharing is gone. I don't know what's the reason behind that. Okay. Is it visible now?
Yes, sir.
Okay, right. Right. So I'll be able to do read from the registers or write to the registers, and from registers I want to read it. From register to registers I have to write it. That all these things will be implemented. Okay, all these things will be created by the template, whatever we are going to create. Okay, right. So user logic, whatever you are writing. So based on that user logic, my data will be written to the registers here. Okay, and if it is writing, it will be the reverse way. Okay, that's how it is created. Okay, and you have the address, right? So this is from the AXI peripheral. So AXI AW address. I'm just giving an example of write address here, but you can have the read address also. AR address also will be included in this. Okay, am I clear now?
Yes, sir.
Okay. Anybody has got any other doubts? I can move further.
Sir, how to decide the size of the registers? In the starting, they have a
Size is declared as 32-bit only.
no, sir. The number of registers. Sorry, in the starting.
The number of registers depends on the design concepts. How many are required for your peripheral? Whether 4 is sufficient or you want to increase more.
That means it depends on the user IP.
Yes. Okay. Am I clear?
Yes, sir.
Right. So the HDL full interface, the XI full will have 32-bit of data interface here. Okay. The right data. Okay. Right, and it will be having 1024 bytes. Okay, so burst transactions if it is included, right? So if it is burst is included, then 1 KB of size memory space it will be included in this. Okay, so what is this memory size? Can you remember, see this here? Each peripheral will have its own range and it will have the address required here, right? The same way, your peripheral also will be included some of the memory spaces required for that, okay? But internally, it is going to utilize some 1024 bytes of memory required for me in my bus transactions for my IP alone, okay? Am I clear?
Yes, sir. Yes, sir.
Okay, that's fine. Okay, right? So there will be an user logic included, some for implementing block memory, it will be there. Okay, so user logic can connect or replace these sections if it is required for us in our applications, right? So what are the files created? It is going to create one XML file, that's IP exact description for us. Okay, block diagram TCL file. Okay, drivers, whatever is required, the C code drivers, whatever is required. Simple register or memory read or write functionality will be included in this. Simple self-test code will be included here. Okay, and in the HDL portion, it will have the Verilog or VHDL inside our project directory. Okay, and they'll be having the GUI file. So if you are going to create some peripherals of some of the controls required for you, right? So I want to control some, like I have created for 16 bits, but in my design I want to use only the 4 bits or 8 bits of my peripheral. Okay, because it may not be required for my the whole design, right? So that's why I can have some sort of customization required for me. That is possible with the help of this uh, uh, the GUI files. Okay, right. So when you create an when you go with edit IP, the new Vivado project will open here. Templates files will be generated and it's added. Okay, now the user can add it accordingly and then start with the help of actions required here. Am I clear? Any doubts to me till now? Yes. Any questions?
Sir, can you show that IP, user IP separately that code, sir?
I have a demo. I'll just start with that one. I'll start.
Oh, okay.
Once my things are completed, I'll start with that only. Okay, right. So let me so this is how this Vivado project will get opened. Okay. So when I go to tools and create new IP, when I go with that right here, tools, create a new package IP. Okay. And when I create a new AXI4 peripheral, so what is the IP name you are giving? So based on that, which repository you're going to start with this. Okay. I can select it and what is the name you're giving. This whole things are right. So when I click on edit IP, all these sections have been completed. Okay. When I click on the edit IP, it will open up the new Vivado project for me. Okay. It will open up the new Vivado project like this, and it will include some of the templates which are generated for me by the IP name what I have given. Okay. And now in the IP, when you expand this IP in these sections, right? So it will be showing you the hierarchy, whether your user logic is required, and it will be this is my template required for me to IP packager and all those things. Everything is created. There will be a lot of things included here. Okay, identification, compatibility, file change, customization parameters, port interfaces, addressing the memory. All these things will be included. And at last, in the below, there will be something called as package IP will be open, or repackage IP will be available for us once you've created for me. Okay. Am I clear? Any doubts to me? Right. So IP from many sources, I can make it as package and made available in the Vivado. Okay. So whether you would have seen in the previous example, I have taken one RTL code and I have made it as a block diagram and I was using it in the Vivado IP. It's also is possible. One particular thing, whether you're going to use Xilinx IPs, some third-party IPs, or user IPs. So this is the job of the IP packager to include all these things, whatever is there. Okay. And the IP packager can take a C code, an RTL or an IP. IP itself can be used for this. That all these things will be an input to this simulation models, example designs, testaments for files, the documentation required, all these things will be given to the IP packager. And if you're going to use any of the IPs from Xilinx, I'll take that Xilinx IPs. If you're going to use some of the third-party IPs, I'm going to use that one. And you've created your own user IP that is also packaged in the form of IP integrator here. Okay, and that will be available as a form in, as a block diagram in my Vivado IP integrator. Okay, right. So when I click on package IP, so package current IP. If you're going with a package current project, okay, then I can the project should be opened and package the generated HDL, okay, right, or package a directory or any other source files. This is also one of the options available for us, okay, right. So if the core is not available, then it will not display in the IP catalog, okay. That's also very important for us, okay. And create a new AXI4 peripheral will also need to be packaged, right. So I can package all of these three flows and make it available in the Vivado project. Okay, right. So IPXAT, it's an industry standard IEEE XML format to describe the IP. Okay, right. So it will have the information about ports, the interfaces, the configurable parameters, the files, the documentations, whatever is required for me, it's available. Okay, IPXAT only describes the high level information about IP, but not the low level description. So it does not replace SDL or software here. So if somebody has created IP and they are shared to you, you will not be able to see those source codes and all those things. We'll be able to see only the interfaces required for us. Okay. Am I clear? I hope it's clear to everybody. Any doubts are there?
No, sir, no doubts in the chat box.
Okay, that's fine. Thank you. Right. So IP packager will automatically analyze the project files and determine the parameters. Initial summary will be there. There will be all the identifiers like files, parameters, ports, interfaces, compatibility, and all these things. And it will create you the GUI layout for the packagers also. Okay, right. So when you see the IP packager, there is something like identification, compatibility, right? File groups, custom parameters, ports and interfaces, address and memory, any customization GUI is required, even the package will be there. Okay, and which category your IP should go, that also I can define it very properly, and I can define which vendor and what is the username, what is the name of the IP you're going to use, and what is the version. Okay, all these things I can define it very effectively in our IP packager. Okay, right. I can go with the IP for use in the IP packager. I can go to the file groups here, and I can see what are the files included in my information, that Verilog code, simulation code, and drivers code, whatever is required. Right, I can go and check it out. That options also. Okay, IP repository, which location, right? So once your IP is created, right, I'll go to this settings of the Vivado project, and in the repository, I'll add this IP, whatever I've created in my design. Okay, and it will get added in my design form. Right? Any questions are there till now? There are no questions in the chat box. If somebody is not understanding, please let me know. Okay. Let's quickly summarize the AXI4 interfaces. What are the channels? Okay, and what is the role of the AXI interconnect? Right, whether it is an pass-through connections or one-to-n or n-to-1 or n-to-m or m-to-n connections, right? And I can create some of the custom IP required for me in my design using the IP packager. Okay, and include those IP repositories for reuse across all the projects. Okay, and I can create and package the IP using the create and package IP wizard, which supports AXI4 Lite, full, and stream compatible IP creations and packaging. Okay, and that will handle the side the interface and the protocols required for us, and it will provide us the template and to add the HL functionality in my design. Okay, and it will package into the IP catalog also. This is what is quickly summarized for us. Okay, so anybody has got any doubts, let me know. Right? Any questions are there till now? Right, so this is what is our sessions now. Okay, right. So the lab, what you are trying to do in this, right? It will be helping you to understand the process of creating and adding a custom IP. Okay, and we'll use and create import peripheral user to create a custom IP and use IP packager to package uh, it for use with IP integrator. And AXI block RAM controller also will be utilized in this. Okay, right. So this is the lab what we are trying. So yesterday you might have seen uh, two GPIOs added in your design. Yes, yes or no?
Yes, sir.
Okay. Now today we are going to create one custom IP and add that in your design. Okay. And we're going to use the block RAM controller and the block RAM memory in the PL sections here. Okay. And there will be one master XI GPU connecting to all these four peripherals, whatever is required for us. Okay. Right. So let us start with this. Okay. Okay. So let us take this project. Okay. So in this, I will start with, is my screen visible? Is it fine? Any questions are there? So if you have any questions, please let me know. Okay. So that I can at least stop at that point and explain to you. Okay. Let us start this. Okay. I'll start with manage IP. Okay. So there is a new IP location. I can say next. So here I wanted to start with which device. I can specify the parts. Okay. Let us take this ping set only. Let us use this. Okay. I can say finish. Okay. Sorry, I think I missed out. Right. So here, these are the repositories it is created. Okay. And you want to see, start with this tools, create and package new IP. Okay. I'll select with create new AXI4 peripheral. So anybody, any doubts are there? I can say next. Here I can choose the name of the IP. Okay. Put it as LED underscore IP. Okay. Just want to give my name here. Okay. And the display name, whatever you want to display it. Okay. And the descriptions, anything you want to do, have it. Right. Our display description is LED peripheral. Okay, just want to give the description. Okay, and which project you can use it. Okay, so it is going to start with some location here. I want to change this location. Okay, just want to give this location to C drive, my CUP. Okay, and create one folder. Okay, create one folder as anything whatever you want to have it. Okay. Okay, and in that location I want to make it as folder as LED underscore IP. Okay, anything like that way I can put it. Okay, and I can say next. Right. So here in this I am going to start with light AXI. Okay, and my light is slave AXI. Okay, I'm going to name it as S underscore AXI. Okay, and what the interface type, whether you want to go with light, whether you want to go with full, or whether you want to go with stream. That's up to you. Okay, and data width is 32 bits, and the number of registers is 4. That's what I told you already. Okay, and is there any interfaces required? You can select it accordingly. You want to add it something, you can add it. Otherwise, you can leave it as it is. I can say next. Right, I'll select edit IP here. Okay, and I can say finish. So once I open that, click on that edit IP, automatically it's going to create a new Vivado project. Okay, and it will open up the new Vivado window also. Okay, am I clear? Anybody has got any doubts till now? Can you repeat again? Which step, my dear friend? Gordon? Okay, I'll close this LED IP what I've created. Okay, and I will close this project also if you want. Okay, I started like this. I'll close this. Okay, so in this.
Hello, sir. Sorry for interruption.
Yeah, I have closed it already. Don't worry. I'm starting from first. If you are, you didn't get any of the information very properly. Okay.
Sir, could you brief what we are doing, because I am joined later, so I unable to connect with this, sir. What we are doing, just could you just brief, sir?
Okay. See, it should not be repeating again because we have a set of timing requirements here. Very importantly, first of all, you should be always on time because we are spending uh, almost 24 hours per day, right? So in that 8 hours we are spending for your session. And requirement is very clear that I want you people to understand what is the FPGA flow, what is the architecture involved in your in the Zinc 7000 series, okay, and what is PS, what is PL. And yesterday you might have seen about what is PS and what is PL, how to connect them very effectively. But today we're going to start with how to create our own custom IP. That is the requirement today. Okay. So in that options, I'm going to start with the create peripheral IP wizard. Okay. I request all of you, please be on time. Okay. If you are joining a little bit late, then you are losing a lot of things. Okay. So be careful about that one. Okay. Right. So we're going to start with the IP creation now. Manage IP. Okay. New IP location. And what is the target device you are that I should choose it. Okay. Let us choose this target device. Okay. And whether you want to go with Verilog or we want to go with VHDL, it's up to you. Okay. Right. And which simulator you want to use, word of simulator. And simulator language, it's a mixed type. I wanted to have it. Okay. And IP location, I am going to change it to my location where I can have a look on that aspects, whatever is required for me. Okay. Let me choose C drive. Okay. And in that I'll go to CUP. Okay. And in that I'll go to this hackathon. Okay. And select that one. Okay. In that I can put name as lab, sorry, as LED underscore IP. This is the IP creation. I want to create it. Okay. I'll put it as custom IP so that it will be clear for us. Okay. And if am I clear, Govardhan? So you can create the directory. Okay. Right. I'll go to the tools, create and package new IP. I'll create a new AXI4 peripheral. Right. So what is the IP name you want to give it? Right. I'll give the name as LED underscore IP. Okay. Okay. And what is this description you want to give it? Okay. LED custom IP. Okay. And which location you want to save it? Okay. This is automatically it is taking an LED custom IP and management IP project IP repository file is there. Okay. In that only it is creating for us. I'll go and say next for this. Okay. And what type of interface, whether it is a light or full you want to go with, I can choose it accordingly here. Okay. So light, full, streaming. So let us go with light. So I just removed that S00 to S. That's all. That's one thing I have made it. Okay. Right. And you can keep it as it is also. There's no problematic. Okay. But you should, according to your Vanilla or VHDL code, how you're creating. So based on that, you'll be able to choose it accordingly. Okay. Am I clear? Any doubts to me till now? Okay. So I'll choose this data width as 7 bit and number of registers are 4. I can say next for this and I'll select edit IP and then finish. Okay. Right. So this
Sir,
will open
whether
up.
it's possible to change after we are finishing like full theme.
See, there is no go back command in this.
Okay.
So there is no go back thing here. Okay. So this is something like which you're creating. Okay. So you can play around with the user logic, whatever is required. I don't have any problem. But this, once this IP packaging wizard comes into picture, then again you have to delete that whole folder and go back to the main project and then start manage IP project. Am I clear?
Yes, sir.
Right. See, it has shown to us this two things here. Okay. When we open up the project, okay. Here, can you see this? It has created the LED IP underscore V and one underscore v file and ldip underscore v1 slave axi instances IP here. Okay, this hierarchy is created automatically by the tool. Okay, am I clear? At least you can say yes, because I don't have any provision to check the chat box in this magnifying wizard. Okay.
Yes.
Yes, sir.
Okay, that's cool. Right. Okay. So this tool is created for us. I'll just open up this wizard to you. Okay. Right. You can see here there are a lot of things automatically it gets added here in this code. Okay. So this is my parameter. What is the width of my AXI? Address width, how much is there? And if you want to add some user ports, I can add it here. Okay. The same way I'll be able to more add some of the logics also in this. Okay. Right. So this is one file what we have created. Okay. The same way I have one more file here. Okay. Just work on this. Okay. And there is an LDIP instances. Okay, this is called here. Okay, and users can add the parameters, right? And if you users want to add some ports, I can add it here also. That's also is possible. In the same way, this code will have a lot of information like all these things like what are the AXI signals involved, slave registers, how to do reading and writing. All these things will be shown to you in this particular code. This is a template automatically created by the tool itself. Okay, right? In the same way, they'll be having one small at the end, there is something called as user logic required here that will be shown to you here in this portion. So I can add that user logic in this location. Am I clear, guys? Am I clear? Any doubts to me? Okay, that's good. Sorry, I'll not be able to see your thumbs up and all because I have made a screen a little bit magnified and all, so to show you the logic very clearly. Okay. If you have any questions, please unmute yourself and at least ask here. Chipping team, if somebody is responding in the chat
Yeah,
box,
sir.
please request
There
you
are no
to.
questions in the chat box, sir.
No problem, no problem. Okay. Just wanted to help you in these cases. That's it. Okay.
Yeah, sure, sir. I request all participants if they have any questions, they can directly unmute yourself and they can directly ask.
Okay. Now let us start with our additions. Okay. So here I'm going to create some of my parameters, very important things required for me. Okay. Right. So here I want to add one parameters to this. Okay. Users parameters are there here. I want to add that parameter. Okay. So my parameter which I wanted to define is a parameter. So I'm going to use Verilog coding. So that's the reason I'm going to use it very clearly. Okay. Parameter integer, the width, what I'm going to define it, LED underscore width is equal to 8. Okay, put a comma, right? If you don't put a comma, it'll give you an error saying that automatically there is error syntax error near parameters. Okay, so the tool is very intelligent, as already explained to you by a lot of the professionals who have taught you in the previous 2 days. Okay, tools the editor automatically checks the syntax and provide you an information whether it is the syntactic whether the syntax is fine or not in your cases. Okay, right? Right. I've added this. Okay, and if there is any ports to be added for your design, okay, that also I can define it here. Okay. The user ports output, whether it's a wire or registers or whatever you want to define it. Okay. And the width of the output is defined by the parameter LED underscore width -1. Okay. Down to 0. And the parameters I'm going to define it as LED. I put a comma in that cases. Is it visible, or you want me to make it a little bit? Okay. I did a small mistake. It should be a square bracket always, not a flower bracket. Okay. Is it visible, or you want me to make it a little bit magnifying? These two things I have defined it. Okay. Parameter integer LED underscore width is 8, and output wire LED underscore width.
Yeah, it is
minus-
visible, sir.
Yeah. Okay. Right. Right. So this I have to add it in this also. Okay. Any parameters to be defined, I have to add it here. Okay. 1 minute. I have to come out of this. Okay. Is it visible? Right. At this point, I have to define the logic required here. Okay. Right. So I hope everybody is aware of the instantiation. Right. I'm going to instantiate those ports, whatever is required. Okay. Which I need to pass it now. Okay. And the ports which we have defined, okay, I have to instantiate that also in my code. Okay. I can save this. Okay. In the same way, I need to open this one more slave AXI. This is what I opened it here. Okay. I can maximize this. Okay. So I'll define that parameter what I have defined in this code. Okay. Same thing, I want to define it again. Okay. Because I'm passing it, but at least that should be defined in the slave ports also. Okay. Okay. The same way, I have defined the output ports. Okay. Output wire LED underscore width -1 down to 0. Okay. And the port name is LED. Okay. Right. Not required to instantiate now. Okay. Just I wanted to show you that this code is having a lot of information about the reading and writing, all these things. Okay. Right? At the last end, there is something which is very essential for me to add is my user logic. Okay. So this user logic, I have to add it.
Sir, do we have to add that parameter and the output things 2 times?
Yeah, 2 times.
Like,
There are two files, my here in this.
okay. Sir.
There are 2 files. 1 minute.
Sir, why is it not necessary to add the remaining things like instantiation?
See, this first one is just calling the module, okay, and it has defined the parameters and the AXI signals, whatever is required for this. And it has instantiated this AXI bus interface, okay, and the AXI bus interface is available in this LED IP v1 underscore SAXI code. Am I clear?
Once again, please repeat.
Okay, so this is my top level file, LED IP underscore v1.0. Okay, this is my top level file. Okay, this is called as this file, LED IP underscore this one. Okay, am I clear?
Yes, sir.
Okay, so this fellow is calling one more hierarchical file. Okay, this is called as LED IP v1 SAXI. Am I clear?
Yes, sir.
This is the instantiation what we have done it. Okay, so this instantiation, what it does is I have to define what are the parameters, global parameters required for my IP, and what is my output of this IP. Okay, so this is going to be an output port or something, whatever is required, and how many bits it is defined by the parameters what we are defining. Whether it is 8-bit or some other bits that I can define it with the help of the parameter there. Okay. In the same way, this fellow is called inside this. That is why I have to recall it again and again. Am I clear?
Okay, sir.
Right. So there is a user logic to be included in this. I'll use that user logic here. Okay. So I'll add this user logic. Okay. I'll define sorry. I'm sorry. I have to add it here in this AXI file. Okay. Okay. Am I clear? So what is getting added here is there is one user logic code which I am defining, that is the lab 3 underscore user underscore logic. Okay, and there is a parameter defined as LED width. That's a global parameter, and the instantiation I required to have the A clock. Okay, and the right enable signal and the right address. Okay, and the right data and my reset required for me and the port which I am defining it. Am I clear? When I save this file, automatically this will create the hierarchy and this will add this user logic logic also in this. Okay, this question mark indicates that file is not available. Am I clear? Yes.
Yes, sir.
Sir, from where do we get this, the thing that we have pasted here in user logic?
To save my time, I have pasted it, but you can type it. Okay.
Okay, sir.
Right. I can type it also. What is the name you want to add it, and what is the global parameters involved in this, and the instance name is U1. I have defined it. Okay, and then what is the mapping of AXI clock to the user logic, and my registers, right enable signal, and my right address should go here, right data, and my right reset, AXI reset should be included, and what is the port required for that I can include it here. Okay.
Okay.
Right. Right. So
Hello.
yeah, tell me.
Hello.
Yeah,
Yeah.
tell me.
Instead of doing this, uh, create block design, we can drag and drop our thing, and then we can use AXI interconnect, and we can get the same thing, no, at the end. Why we need to do in this
I
long
am
process?
creating my custom IP, my dear friend here.
Yeah, we can create our custom IP, no, there also.
But I want it to be AXI format. I need to connect to the processor.
Yeah, AXI interface you can keep, and you can keep our, what you'll say, our logic,
How
and you can do run automation.
how is it, Gordon? Even I'm not aware. Let me know.
Yeah, we can do create block design.
Okay.
In that create block design, we can take AXI interconnect. AXI interconnect is going to be there, whichever the logic you would have written in RTL format. That thing you will drag and drop into that, what you'll say,
But how will you
IP
connect
thing.
it? How will you connect it?
You can do run automation. There it will connect automatically.
Let me if you're having this, okay. Let me show you a small thing, okay. Gordon, if your IP is not AXI format, then how will you connect it? My question is that one. If your RTL, you have written just a simple RTL code, Verilog code, how will you connect that to AXI? My question is that.
You will connect our RTL to AXI interconnect, you will connect. That thing will be connected externally, no?
How can you do it, my dear friend?
Isn't it
When
possible?
your RTL code does not have any AXI signals, how will you do it?
Okay, I thought we can do.
My question was that to you. My question was that to you.
Okay.
Okay, because a lot of people get confusion why this process we are doing it. Okay, the reason behind that is I am creating my IP with the AXI logic inside this. This is your user logic, and this is having an AXI connectivity. Okay, and it is going to talk to the AXI template available created by the created custom IP wizard, and this will give me a AXI signals like this. Okay.
Okay.
Am I clear, Gordon?
Yeah.
Right. So if you are still not very clear, let us just open this small project what we have created. Okay.
Not required, I understood.
You understood it, right? Okay, then it's fine.
Yeah.
Just keep it as it is. Okay. Now I've added this logic here. Okay. And I've included the AXI signals also required for me. Am I clear now? This is my logic, what I've included. Okay. And AXI A clock, slave register write enable, AXI AW address. Okay. Which is connected to the AXI address width of your AXI IP. Okay. And the write data signal and your reset signal and your output port, what you have defined it. Okay. Am I clear? Right. So I will add the source. Okay. I can add or create a design source. Right. I can add the files. Okay. Right. So for your reference, I am just putting those files in the chat box also. You can add them files, okay? I don't know whether in Teams we can add the files. Is it possible to share the files, Chipin team, in the chat box?
Which file you are going to share?
Just to showcase them that how we can add those files, whichever is available.
Yeah, that you can do.
I think it's not allowing me here. Okay.
You are
The chat
co-host,
box.
sir. You can do that.
Okay. Okay, I'll share those files a little bit later. Don't worry about that things. Okay. Maybe possible I can I think a lot of people have created the WhatsApp group, right, for me?
Yeah, sir. WhatsApp group is
Yeah.
created. There you can also share.
Sure, no problem. That's fine. That's also is fine for me. Okay. Okay, so this is the logic what I'm creating. Okay. And please make sure that you have added these files included to your project. Okay. Okay, sorry. You can do either one, not both. Okay. Add files. User logic. Okay. Either scan and add RTL into this file project, copy source info to the IP project repository. Okay. Anyone we can do it. Right. So I can choose this copy sources into IP directory. I can deselect this. Okay, and add this into this project right now. Okay, so that my source code will not get shared to anybody. Right. So this is the code what we are defined. It's very simple code, not a this how I defined it. My input is a clock, then the slave register I enable, and my address XI AW address is of 3-bit, and my data is of 32-bit. Okay, and my register output is LED, which is of LED width -1. Okay, always on the positive edge of the AXI clock. If my reset is 0, then my LED should be 0. Okay, else if my reset is not 0, then this slave register I enable and my AXI AW address, it's of the 3 bits, right? If it is 0, then based on the data available on the W data should go, the 8-bit of data should go to the LED port of my design. Okay, this is a simple design. It's similar to like you're writing for a register, like for a flip-flop or something. Am I clear? Yes, any questions to me? Let me tell you to all the people who are present here, don't ask the presentations because we are giving sharing the recordings to you. So there is no requirement of sharing the presentations. Okay, please do not ask again and again the same questions, right? Am I clear?
Sir,
Yeah, tell me.
sir, we have written some code in user logic, sir. User logic. After we got question mark, we have added that user logic files.
Yes.
Where it was while we are writing that code, it is creating a file or what is
No. I told you, no. See, when I click on this, let us take this, remove this file. Okay. Remove this file from the project. So I can go to add source. I can add files or create files are there here. Okay. If you start with create files, then it will ask you what is the file name you want to give it. Okay. The same process what you have done it in the previous 2 days. Create a Verilog code, write things. That process is also included here. Am I clear?
It is a file, a simple Verilog code.
It's a simple Verilog code only it is.
We have to write that code.
Yeah.
And make it as a file.
Yeah. Which location you want to add it, that is up to you.
Okay.
Okay. So to save my time, I have just added the files which is created for me. I can share these files. There's no problem. Okay. Am I clear now?
Yes, sir.
Right. Right. So this logic has been added here. Okay. Just synthesize the design. Just synthesize the design. By the time it's synthesized, we'll wait for some. Any questions are there for me? Yeah. Any questions? Any questions are there?
Sir, in the else part, you have given the address now, sir. That's like AXI underscore A address. That address we need to assign by ourselves.
This is the right address, this is the AW is the right address for the peripheral. Okay, right.
For
So
this,
what is happening? No. Let me complete here. So this IP is having this right address will be available here for me from the AXI template what we created. Okay.
okay, sir.
It is going to come from the AXI peripheral what you have created here. Okay. So no need to worry about that. What is that address and all. That's it. Okay. Am I clear?
No, sir. This logic has to be created by ourselves now, sir. So we need to know the address.
No,
Value.
see, this is a simple logic written for me here that whatever is available on my W data has to go to the LED. Okay, and that depends on the right address portion of my peripheral. Okay, this right address, the AW ADDR is there, right? So this fellow will get the information from the peripheral what we are going to create it. Whether if you don't have this equal to 0, so this is some simple logic written here is SLV underscore reg underscore right enable double ampersand of AXI W order is equal to 3 tick H0. If this is 0 and this is some other things, it will not execute this code because it's a AND gate. So AND gate will work with at what logic? Yes, can you give me the answer? If it is 0 0, AND gate is what? Your voice is breaking actually. I think.
Oh, my.
Chipin team, is my question clear? My voice is clear to all of you?
Yes, sir. Your voice is clear, sir.
My
So
question
now
Karthike,
is,
my voice is
there,
clear.
Karthike, yeah, you can, yeah, please proceed.
So my question is, you have
no, my question is first, before going to your question, this
okay,
if
sir.
statement will be executed in which cases?
When that slave register right is high and the address is 000.
If this is the AND gate actually, so double AND.
So both
So what
are
is this mean?
both results to one, sir. So the
No,
slave register WRN should be high, which is one, and the address should be 000. So the condition will be one. So both should be one.
okay. Both should be one or both should be 1 and 0?
Both should be one, sir.
No, you told in different format. That's the reason I'm asking the question to you.
No, sir. Both should be one. Why? I
This
said that the
should be
address
one.
should be 000.
No, if it is address is 0, then this statement will not execute. No.
No, sir. The address should be 000. So though, then only the equal to sign will be results to one. If the addresses differ from 000,
Yeah,
it will be
that's
results to
correct.
0.
Okay. So this address is 0, you're telling. Okay, but this should be
Yes.
1.
Yes, sir.
Okay.
Results.
Yeah. So this
So,
address should be always the 000. Okay. This is the right address what we are taking it, right? Okay. This is about the light information. If you have a full thing, then this code will not. Am I clear or not?
sir, your screen has been off and your voice has broken.
I don't know what's happening. My voice is clear, I guess, but only
Now
why
it's clear, sir.
screen is visible, not visible because
Now,
it's
okay.
something else. I don't know because maybe it's a problem with WebEx. Sometimes it gets disrupted in the middle.
So, my question is how we decide that the address of this IP should be 000. That's it.
No, we are not defining here. So, my dear friend, I am trying to tell you this is a 3-bit signal which is coming from the AXI IP. Okay.
That's only, sir. I'm asking. We have written the
Okay.
logic, no, sir. The address should be 000. Then only I accept the data
Yeah.
from the
Yes.
W
So it is
data.
something like
So,
one flip flop. I'm going to create one 8-bit flip flops here, 8 flip flops separately. So one flip flop separately, right? So this data is going to assign to that value, okay, for the whole of that eight flip flops registers. Sorry.
that will be assigned only if the address is 000.
Yes. Otherwise, it will not assign at all.
I am asking
That is my
whether
peripheral.
that value should be decided by ourselves or it will be decided by software itself.
See, this is defined here. Okay, AXI AW ADR. Okay, and I will search for that here in this. Right. So AXI AWDDR is from the AXI address width -1 address LSB. Is coming from this signal. Okay. Am I clear?
Yes, sir. I'm not asking where it come from, sir.
No, it's coming from this. It is coming from this
Yes,
IP, my
sir.
dear friend.
It's
It's coming
coming
from the
from the
IP.
outside, maybe from a master, but I'm asking whether
Yes.
how will we decide this is my user address. So for this address, I need to respond for the master.
That is what I am trying to show you in this figure here. In this IP
Yes, sir.
case, AXI AWDR, if it is 0, byte index should go to this value. The slave register to get the data from the register 0. Okay, if it is 1, it is from this byte. Okay, if it is
Okay.
2, it is from this byte. If it is 3, this is from this byte. It is going to create it from the IP itself. Am I
Okay.
clear now?
Okay, sir.
That is what I am trying to explain to you, Karthik, from
Okay, sir.
that time onwards. Okay. Right. So as a user, yes, you have a questions that why this 0 is coming, because it is coming from this case statement here, from the IP template. Am I clear? If you
One
go
second.
through this
Pause.
IP template, if you
I'll
go
be
through this
more
IP,
clear from 1 second.
come again.
Can you pause for 1 second? I will go through the code and I'll be more clear.
Okay, right?
Okay, sir.
So now I have synthesized the design, okay, and I'm able to see that how much lookup table it is taking. 57 lookup tables, 178 flip flops, all these things. There are no block ramps, other things involved in this case here. Okay, right? So once your since things are finished, I can go to this package IP. Okay, so it is going to create in this peripheral XI4 peripheral identification. What is the name you want to give? Okay, see, my company has got this core.com website. Okay, you want to give the same name or you want to change it to your accordingly, or it will be sometimes it will be blank. Okay, it's up to you whether you want to use it or not. Okay, so I'll put it as xilinx.com just for my understanding purpose. Okay, right? Am I clear? Any doubts to me till now? Right? So whether you want to add this peripheral to some other logic, some other uh, mm, IP catalog formats, whether it is something like basic elements you want to add it or you want to add some separately AXI peripheral, it's up to you. Okay. Right? If I change it to basic elements, I can go, it will come automatically to the basic elements peripheral here. Okay. I can remove this if you want. So it will be in the basic elements always. Am I clear? Yes. Any questions to me? Any questions? No questions? Right? So there is one more tab called as compatibility. So what does this compatibility means? So compatibility means I am creating an IP for one particular device, but I want to use that in some other devices also. I want to add it, right? So I can add those files, okay? Add family explicitly, okay? Let me choose this Zinc Ultrascale Plus also, just for my understanding purpose, okay? Right? And I want to use it for pre-production or production boards, whatever is required, I can use it accordingly. Okay, just to inform you that this is supported, you can use it. There's no restrictions here. Okay, am I clear? Am I clear, guys?
Yes, sir.
Okay.
So if we add the some other family, whether we can see the synthesis for that family also.
If you have a license, there'll be no problem. If you don't have the
Oh.
license, there'll be a problem. Okay, that's a clear-cut answer from my end, right? Because some of the devices will not be supported in some of the if you have installed some Webpack licenses, it will not be supported here, right? Right. I'll go to the file groups. Okay, you can have a just look on this file groups. Okay, right. I can expand it. See, you can see here. This is the Verilog files created. So till now, it has not added the user logic code which I have defined it. Okay. Right. I hope it's clear to all of you. Right. Any questions are there to me till now? Right. I will. If you see that there is something called as merge changes from the file groups wizard, we are having it, right? So if you click on that, automatically it gets added the files, the user logic files in my design, what we have created. Okay. It's going to add it in synthesis part, simulation part, right? All these things. So if there is any drivers required, automatically it gets added here. That's what I just wanted to say it to you. Okay, right? There is some descriptions here. There is something added to this. Right? Okay, right? Customization parameters. Oh, sorry. Right? So I clicked on this merge parameters. So it came to the hidden parameters here, which I want to add it. Okay, right? I'll right click on this and say export, sorry, import IP parameters. So based on my code, it is going to add it here. Okay. So I can select this customization GUI, right? So this is how it looks like. So any questions are there?
No, sir. No questions in the chat box.
Okay. Right. So I can go to review and package and say there are packaged IP. Okay. So it will ask you to close the project. You can say yes for this. Any questions to me till now?
Sir, but it is showing some errors, sir. Is it fine to pack it like that?
Where it was showing errors, it was my first error I created when I was adding that files. It didn't add any errors. It got synthesized, right?
Yes, sir.
Okay. Any questions to me till now? Right. So if I go to this, right, if I open this project, I can close this project. Already it is created now for me now. Okay. Now I can create one project. Right. I'll select this. So yesterday, whatever you have created the files, I'm just taking the same files. Okay. I'll create a design. create a design, block design. Okay. Right. Right. So I'll go to the settings here, and my IP repository is there, right? So I'll add that IP repository to my code here. Okay. You can select this IP repo, or you can select the custom IP also. Okay. Right. So it is going to guard this LD IPs, whatever you created. Fine. Okay. Right. Any questions to me till now? Right. So yesterday, whatever you have done, I'm just adding it one more time. Same thing. Okay. Right. I'm going to add the 2 ports. One is my switches. I'll rename it as switches. Okay. And my buttons. I'm going to create separate. Sorry. Okay. I'm going to add separate module for that. Okay. Buttons. Okay. Now I want to add my IP which I have created. Okay. So for that, I will add this IP from here. Okay, I'll select LED. Okay, so it's going to create like this. Create me an LED IP like this. Okay, am I clear? Any doubts to me till now? Any doubts till now? Can I get answers? At least yes or no. Right. So I want to add my LED bit as 4-bit. Okay. I have created the IP for 8-bit, but I'm taking it for only 4-bit here. That's what is required. Okay. Right. And I'm going to make this peripheral as external. Make external. Okay. I'll rename this port as LED instead of LED 0. Okay. Okay. Yes. Any doubts to me till now? This up to this yesterday you might have seen it already. Okay, I'll add one more memory block RAM memory controllers. VRAM memory. Okay, right, and I want to make this block RAM memory as interface as only one, not as two. Okay, so only one port I want to add it here. Okay, so there is no requirement of adding any ports to this. Okay, I'll make the connections automatically. Right. So any questions to me till now? I've added this automatically, all the portions, whatever is required.
Sir, can you please show the customization for AXA BRAM IPC?
I just double clicked on it and I added, made this number of BRAM interfaces as one. That's all.
Okay, sir.
Okay. It will be a 2-port memory, so I'm using only 1-port memory in this. That's it.
Yes.
Okay. Validate design. Okay, so there are no errors. And I have created a block diagram here. Okay. Right. So let me just create an HTML wrapper for this. Right. This LDIP is still, it will not show any of the other things. Okay. Right. So, but I just need to run the synthesis. Let me run the synthesis for this. Okay. So now my question to all of you is, did you give any constraints, IP constraints to the design in the RTL code? Any constraints? IO constraints, sorry. Did you give or not?
As of now, we haven't given. Sir.
How is it possible? First day it was of IO pin constraints have been shown to you know how to give the constraints.
No, sir. That day I'm telling about for this design tool.
No, come again.
I thought that you have asked for our design.
Not for this design. I'm asking general questions. I'm asking how to give IO pin constraints. If you write a Verilog code
from that add sources.
Okay, then
And then we can give whatever the like it will create some file and we can add that from .xdac file.
Okay.
Whatever the pin we wanted to add.
Okay. Any other methods?
Else we can add from the transcript also, sir. While design runs, we can add.
Okay. Any other methods? I don't know how you add it through transcript window. That's I'm not sure about that one. If the constraints files are ready, then you can add it. That's what you mean to say?
Yes, sir.
Okay, then it's not between only you and me. Somebody else also can answer it here. Yes. How you can give the pin numbers I can open the elaborated design and I can go to IO planning and start giving the pin numbers. Yes? Do you agree with me? Or I can open the synthesized design and there is an option here. This option is the right default layout is there, right? Once you open the synthesized design, I'll be able to see the IO planning, IO pin planning, and I can give the pin numbers there also. Yes, do you agree with me? Yes or no? Yes. At least you can say yes or no for this. No answers. Why? Yes or no, at least. At least you can say yes or no to answer, no? You're taking so much time to answer my questions also, my dear friends. Right. So here I can open the synthesized design. Okay. You open the synthesized design. Okay. See here, I can go to IO planning, right? And I'll be able to add the pin numbers like this. And I can save it. So once you make it, save it, automatically it gets saved as a .xtc file in this constraints file. Yes? Do you agree with me? Yes? Dinesh, today 10 to 5 is the whole session is about uh, Chipin team. I think you have already you have mailed them very clearly the instructions, like it will be for 10 a.m. to 5 p.m. Right? So no need to
Yes, sir.
be
Already emailed also, and in the WhatsApp group also. Whenever we posting any link for the meeting, it is mentioned there also from
check
10
out.
a.m. to 5 p.m.
Right.
Ah,
Okay.
Dinesh, we will schedule lunch break in between 1 p.m. to 2 p.m. and then there will be a session after the forenoon session. There will be a session.
Okay.
Yes.
Michael, is this understood? How to give the pin constraints? This also is one possibility way. Okay. Am I clear? Any doubts to me till now?
Sir, please can you one step to
I have opened the synthesized design. Okay. In this, I went to IO pin planning. Okay. So this will automatically show me this IO ports available in my RTL code. Okay. And I'll be able to give the pin numbers in this package pin options here. And what is my IO standard, that also I can give it. Or you want to type it, you can type it like this way also. You can type it like this also. Okay.
Okay, sir.
And you can add it in the XDC file, what you are saving. Am I clear?
Yes, sir.
Okay. Right, so we are about to finish it. Just another 5 minutes. It will not take much time of yours. Okay. Right. So it is synthesizing now, almost in the finalizing stage. Okay. So we have almost completed. So it is around doing initially it started synthesizing all the subblocks, whatever is available inside my wrapper. Okay. And now it is doing the synthesis for the top level file. Okay. Am I clear? Any doubts to me till now? Let us open the synthesized design. So I'll just make this eye-opening planning, okay? And I'll give this. You can have a look on this. So this gives us very clear lot of information in this eye-opening planning. So already it has taken the pin numbers for the buttons and my switches, all these things. But it has not taken it to LEDs. Why? Why? The reason is very clear because it is your custom IP. It's not a board definition IP, board defined ports. Okay, right? So that's why I need to give the pin numbers for this ports as per our requirement. So I will start with 0. Okay, so this 0 pin number is my M14. Okay, I can get it from the constraints file, master constraints file, which I have defined it already, which you are aware of it also. Okay, I hope a lot of people are aware of it, or if you're not aware, let me know. And my IO standard voltage is LVC MOS 3.3. Okay, save this file. Pink.xtc file. Okay, right. So any questions to me till now? I can generate the bit stream. I can clip it or keeping it, running it out very properly. Okay, right. So we can take a break for lunch. Okay, and once we'll be back at around 2 o'clock because here today I have to go out for a lunch. No, it's not available in my office today.
Okay, sir. No problem, sir. So we will meet around 2 p.m. Is that fine,
Yeah,
sir?
yeah, it's fine.
Yeah, sure, sir.
Anybody questions are there? Anybody has not understood anything?
No, sir. No questions in the
Okay,
chat box.
that's fine. That's fine. Okay.
Okay, sir. Okay, sir. Thank you, sir. We will out for lunch break for 1 hour. Then we will
Yeah,
resume our session.
sure. I'll be in the meeting, Prince. Okay, but I'll be unmuting myself after 2 o'clock. Is it fine?
Yeah, sure, sir. I will be also there in the meeting.
Sure. That's fine. That's good. Okay. Okay, guys. Meet you at 2 p.m.
Sir, you said something?
Yeah, I said we'll meet at 2 p.m.
Yeah, sure, sir. No problem.
Okay, right. Thank you. Hi, Prince. Good afternoon.
Yes, sir. Good afternoon, sir.
Yeah.
So I request all participants please join back. We will be starting the session in few minutes.
Okay, sir.
I can see very few are there right now.
And there are just only 4 or 5 people, sir.
Yeah, sir. We will wait for a few more minutes. 5 minutes more.
Sure.
I hope all team members and their leaders should join.
Okay, sir. Right. I'll just wait for some more time.
Yeah. Ilyas and Mohit Verma, yeah, please ask other people also just join back. The team members and other people, yeah. So we'll be starting the session in about 5 minutes. Yeah, people are joining back, sir.
Yeah, okay, sir. We'll wait.
Hi, Prakash sir. Let's start the session.
Okay, that's fine.
And that.
Okay, good afternoon. Welcome back. I hope my screen is visible.
Yes, sir. Screen is visible, sir.
Right, that's good. That's good for me. So I hope yesterday they might have explained you about application development. Can I get the answers at least? Oh, okay. Right. So now we will be seeing about what are the things which we do it in application development. Okay. So generally, when we start with the application development, it will be a lot of spaces will be created, a lot of things will be created, right? So in that aspects, we will be having a lot of information like this. Okay. Okay. Right. So when we start with the Vitis environment, we'll start with the workspace. Okay, so the workspace is the location where our preferences and other internal information about the projects will be stored actually, and it will be transferred to the users files. Okay, and source files not stored under workspace very clearly. Okay, so it will be having its own SRC folder. That's what we'll be doing it. Okay, they'll have a lot of waivers and editors will be available, and there'll be different perspectives, debug perspective and C++ perspective will be there according to what your requirement will be there. So based on that, we'll be choosing it accordingly. Okay, right? So when we start with the workspace, right, it is something like where the physical location it will be stored for the Vitis IDEs. Okay, and it will have different information about different projects created there, platform project, right? So it will be having which domain it is, whether it's a hardware specification file is created by you or it's by default available, right? And we'll be having the first stage bootloader, and we'll be having something called as PMU firmware, which is available only for the Zinc Ultrascale plus MPSoC. Okay, and the system project will have the application project for which domain you are working out what. Okay, right? And as I mentioned you, we'll have different perspective. It is either design perspective or it will be on debugging perspective. Right? Based on that, the view will change accordingly for that one. Okay, right? So this is the domain. So we need to create the domain first. Okay, the domain is something which is a software tied to a single processor or cluster of different kind of processors or single kind of processors. All these things. Okay, and it will contain all the board support packages, operating systems with software drivers. All these things will be included in our domain things here. Okay, right? And the standalone application project. If you are going with bare metal applications, then it will have standalone application project. Okay, right? It will have the source files, the header files, right? And all the information required for me to create the project will be the linker script, everything will be there in the standalone application project. Okay, and once you compile that standalone application project, it will create an ELF file. So what is the output of the Vivado project you created, the hardware project you created? What is the output? Which will program it to FPGAs. Which file it is? It's a bit file, right? Yes or no?
Yes, sir.
Right. Okay. Right. In the same way, while we creating, the first step is the platform project. Okay. So the platform project is created using the help of one very important file that is called as our hardware specification file. Okay. And the first stage bootloader, and even the firmware required for me, right? And I can have one or more domains also in that hardware specification, okay? And the boot support package contains the software support for the hardware what you have created for this year, okay? And your application project is created based on the domain, okay? And based on that domain which you have created for the platform project, okay? Right? And it will have all the source files and header files required for us very clearly. And system project is one that is groups, the application that run on device simultaneously. I can have multiple applications running on that aspects over there. Okay, right? So this is the projects how it looks like. Okay, so I've shown you slides with something domain with Cortex A53 also, keeping in mind for sync ultra scale plus MPSoC also. Okay, right? So I'll have this workspace. In the workspace, I'll have platform project. Okay, and the application, the platform project will contain different domains for A53, R5, or if you have Linux on top of it, that is also will be included over there. Okay, and it will be created with the help of hardware specification what you have created. So based on that, the domain will be created for us. Okay, so multiple domains will have different applications. Okay, the application one can be on Cortex A53, application two can be on Cortex R5, and if you have Linux application system project two, which is running standalone application one for Cortex R5, that will be separately available for us. Okay, and if you have Linux running on that, there can be multiple applications running on that one, right? So demand system project 3, including with Linux app 1 and Linux app 2 very properly. Okay. All our application project will have C or C++ source files and the output files compiled after that, and it will have associated utility files also, right? So very important thing, I just wanted to have it, right? Two same processor standalone applications cannot be on a system project. Okay, right? So if I'm having system project 1 and if want to create application 2 for Cortex A53, it's not possible. Okay, in the same way, system project 1 and system project 2 are there here. There is a standalone application 2 running on Cortex R5 and there is a standalone application 1 running on system project 2 here. That can be possible. Okay, right? Whereas Linux applications can be on same system project, no problem. So these things you should be always keep it in mind, right? So when I say Linux systems, it is something like which I wanted to port Linux on my hardware design. That's also is possible with the help of this. Okay, so this is how the C or C++ project will look like. Okay, right? I can have the application project, then the source file required here. It will be showing to you what are the platform project created, what is the hardware description file information will be required to you. It will be shown to you in this project files here very properly. Okay, you just double click on the file to open the file and access it very properly. Right click and access the properties also using the right click mouse button of the mouse. Okay, right, this is the outline view. Okay, right. I hope it's clear that yesterday you might have seen this window already. Okay, if not, I'll just open that window and showcase to you just to have a look on that. Okay, right. I'm just opening the Vitis classic window. Okay, right. So these are the windows I was trying to explain to you very properly in this case. Okay, so this is my Explorer window. Okay, and this Explorer window will have the platform project, the application projects, whatever is required here, that is shown to you in this case. Okay, and this is your outline window. Okay, so this is your outline window. So outline window will not get open anything until unless you open this files here. Then you can see here what are the files included in this. It will be shown to you in this case, outline window. Am I clear? Any doubts to me? Any doubts till now? Right. So all our defined hash defined statements from the C source code, it will be shown to you in these cases. Okay. Right. Right. So content types is indicated by the icon. Okay. And include files, function files, declarations, all these things. And you can just double click on this to go to that outline window and check it out very properly. Okay. Right. This is our C++ perspective, what we call it as. Okay. So this is the window, how it looks like. This one, design window is there. This is C++ perspective, we call it as. Okay. And there's one more window, debug perspective, we call it as. Am I clear? This is a project outline, this is the editor view, this is the code outline, this is the console, and this is the assistant wizard available for us in this very properly. Okay. Right. Any questions are there to me? Are you able to hear me or not? Yes.
Yes, sir.
Okay, right. Let's go to the things. Okay, I can open up any of the wind perspective, what is required for you. You can just click on this. The show view will be to check it out if there is any perspectives open. I want to see something on the highlighted window. I can go and select it accordingly. Okay, right. So this is the syntax highlighting. Okay, so it will show you very properly this coloring with different coding styles because editor is so intelligent nowadays. Okay, and because of that, we'll be able to see very properly where my project is created. Right here, you can see this. So this is a bracket opened, and from here it is starting and it is ending to this one. So this whole thing is my code lines, whatever required. Okay, just to showcase to you, if I have some other code, okay, so it will show you very properly the code lines from here. This is just a one loop. Okay, so if you have a loop or something, it will show you like that. That way also it will be shown to you. Am I clear? And these are all my header files included for that. Any questions? Anybody is not understanding it? Right. So to create the project, I can just export the platform project what I have created. Okay, and once my project is created, okay, right, and that project, whatever is required for me, is available for us. Okay. Right. Is it clear? Any doubts to me till now? So this, before going for lunch, we have just done this project. Okay. You want to see the implemented design? You can open implemented design to have a look on that. Right. So is your processor side, and these are all your PL side included here. This section is processor. This whole section is there, right? So this section is my processor. Okay. And this is my FPGA sections. Apart from this, all these other sections are my FPGA sections. Am I clear? Any doubts to me? At least you can respond in chat box, yes or no, at least. Okay. Right. So let us move further. Already you might have seen about those things already, how this Vivado is helpful to us. So this is my block RAM memory. Okay, this is my block RAM memory, what I have included in this. Okay, am I clear? I just want to show you this whole thing for us. Okay, I'll just save this project as one of the project. Okay, lab 4, just for my understanding purpose. I'm just doing it, nothing else. Okay. Okay. Right. So to start with the platform project, how this can be started is, I need to export my hardware definition file from the Vivado. Okay. So from the Vivado, I can go to File, Export, Export Hardware, say Next. Include the bitstream also, because I'm going to program the PL sections also in this. Okay. And which location you want to work it out, it's up to you. Okay. So I have this sorry, I think I created this. Okay. 1 minute, I'll just close this. Okay. Okay, let me open this tree only. Okay. Right. I will go to File, Export. Okay. Export Hardware. Include the bitstream. Okay. Say Next. And which location you want to add it, it's up to you. So I'll put it as lab 4 just for understanding purpose. And my XSA file name is system_wrapper. You want to put the same name or you want to change the name, it's up to you. Okay. Right. I can say next for this and then finish. Right. I'll close this with this IDE. Okay. Right. So I will open up the Vitis window from here. Okay, so I can go to Xilinx Design Tools. Okay, and there is something called as Vitis Classic 2023.2. You can install it. Okay, so you can open that window. So once you open it, automatically it opens up the. It'll ask you for the workspace location where you want to work it out, right? So my location is very clear. I want to go to the C drive CUP. Okay. Then this hackathon and lab 4. This is my workspace location I want to work. Okay, so this is how I'm going to create the project. Okay, so once your workspace is created, first I should create the platform project. This is the first step I should do it. Am I clear? Right. So enter the XSA name and whatever is required for us, and which operating system you are going to use, and which processor you want to use. All these things you should define it very properly. Okay, right. So always your platform project should be associated with the hardware description file name. We call it as XSA. It is a Xilinx shell archive file. Okay, I can choose either standalone or Linux. Okay, so for time being, you please concentrate more on standalone only, because I don't want you to get confusions with the Linux operating systems. Okay, all right, but you can do it. Keep it in mind. So I don't want to people to understand that it's not possible to put there. Okay, Linux on top of the design, on top of the board, what you required. But for that, I need to install Petal Linux and all those tools required for me in Linux Ubuntu machines. Okay, am I clear? Any doubts to me till now? Any doubts are there? Let me know. Any doubts are there?
No, sir, no doubts in the chat box.
Yeah, okay, I'll just move forward. Okay, right. So once my platform project is created, I'll create the application project. Okay, I can choose a lot of multiple application project I can create it. Okay, right. So there are some sample applications also available. You can have a look on those sample applications, right? So you want to have hello world applications, you want to have some sort of peripheral test applications, right? You can choose accordingly and you can compile it. Okay, but if you are going for starting from scratch, then you should go with an empty applications always. Okay, right. So this is how the directory will be available for us. Okay, right. So it will be in the workspace directory that how the Vitis ID is launched actually, and it will have multiple directories for systems files and configurations. Okay, so configurations will generally have a property tool options, permutations of the software applications, right? All these things will be created. Okay, and each configuration project will have different properties based on the depending needs, whatever is required. Okay, that's how it is there. Okay, I can have release configuration, debug configuration, and profile configurations. Okay, by default, debug configuration is created by default for us. Okay, right. So this is a domain and board support packages. Okay, I can select this domain software, whatever is required. Okay, then this board support packages will be available for us on the Vitis environment available for us. Okay, right. So there are some already the BSP services are available from Xilinx only. There are standard APIs are also available, right? So no user maintenance of this BSP is required for us because it's already predefined available things from the Vitis environment available. Okay, right. So standalone support a lot of things, processor services, some drivers, right? And the hardware platform, whatever we created, right? So based on that hardware platform, all these things will be available for me in my platform project creation, whatever I have created for this. Okay, right. So this is how the board support packages will be available. Okay, so if you can once 1 minute, okay, I'll just do one thing in this is I will create the project and it will be helpful to use to start with this. Okay, right. So I'll create a platform project first. Okay, right. So what is the platform name you want to give it? Let us give it as Lab 4. Okay, this is the platform name I want to give it for this Lab 4 Plat. I can say next. Right. So here I should specify the XSA file which I have exported from my tool. Okay, and this is the XSA file I got it. Okay, right. So by default the XSA file will inform us which processor I am having it. Okay, so that will be shown to us. So no need to get worry about what are the things involved in our application things and other things, right? So it will show me what processor is available, Cortex NN 0 and 1, because in my Zinc architecture, I have dual ARM Cortex NN processor. Okay, so for that, I'm going to use the Cortex NN 0 and Cortex NN 1 for that. Okay, so when you click on generate board components, the FS build project is created by default itself. If you don't want it, means you can just disable this. It's up to you. Okay, but generally we prefer to have this boot component so that it will be helpful for you to create the boot files, boot image files, and use it accordingly in your locations. Am I clear? Okay, so I can say finish for this. Right, so I'm creating the platform project first here. Right. So once it is done, I'll show you that the whole structure, what I am presenting to you. Any questions? Any questions to me? No, right? No, I didn't see anything in the chat box. Okay, I can build this project. Okay, so this is what I was trying to show you. The DSP is available here for us, include files, all the files, lib source, and whatever you have included in your platform project, it will be listed to you in this drivers automatically. That's what I'm trying to show you in the slides. Am I clear? Yes. Yes. Any questions are there? Any questions are there? Anybody is not able to understand? Please raise the request now only. Right. So these are all the driver files available for me for my peripherals. What I have included, either it can be on PS side or on the PL side separately. Okay, there will be a lot of board support packages included in this. Right. So it will have all the source codes for the for your peripherals what you have created. So you can see this. This is the URPS source codes will be there. It will be showing you the .c files. Everything will be shown to you in this case. I hope it's clear. There are 10 people now. Okay, Ajit, Atharva, Durga, Ilyas, Lokagna, Karthikeyan, Mohit, Sandeep. Yes or no, at least.
Yes, sir.
Okay, right. So there are the board support packages, source code drivers, what I have shown to you in this case. This is what I was trying to explain to you. Slide. Is it clear? I hope that's the information I wanted to show you. Okay. So they'll be having a lot of processor services, interrupt management, cache management will be there, processor register management will be there. I can see them very appropriately. Okay. Right. And it will be having the HL. Okay. hardware abstracted layers, what we got as, okay. And there are some set of functions and programming resources for that also available here for us, okay. And device drivers. So whatever the devices you are having it, right? So those device drivers will be available for us for using in our applications. So I can select that one and I can use it in our applications. And if you are writing your own customized IP and you want to write a driver for that, yes, it's possible, okay. You can write it in ANSYS or something like that way, and you can have customization of driver code also is possible, and it's modifiable also, okay, right? So Xilinx device drivers will be available for me in a part of as a part of the board support package is what we created, okay, right? So if you generally what happens is the device drivers will have multiple different options, like it will be having lower level drivers and higher level drivers, okay, right? So generally lower level drivers means, for example, if I'm taking an example of UART, right? So it supports only character reception and transmission very properly, okay. Whereas if I go to higher level of the same peripheral drivers, I have to have some sort of handshaking signals are required, CTS required, some other things are required. Those things or some interrupts are required for that one, right? All these things will be available for the higher level of drivers available, okay, right? It depends on the OS dependencies, and there'll be different layers of approaches for separate device communications from OS dependencies generally, okay, right? So there'll be generally lower level 0, level 1, and level 2 drivers generally will be there, okay. If you take up level 0 drivers, it will be simple use cases. It will be like, for example, if I take a general purpose input output GPIOs, okay, I can do reading and writing operations of that one, okay. The same way, if I go to higher level drivers, that will be having a lot of full-featured options available for me, and it will be portable across the different operating systems and processors also, okay. And level 2 will be always our OS layers, option layers will be there for us, okay, right? So the level 0, it will be having low device drivers, okay, and a lot of things will be implemented as macros and functions that are designed to allow developers to create small systems, okay. So characteristics is very clear. It will be having very less small memory footprint, and no error checking is performed for us, okay, right? It supports primary device features only, no support for device configuration parameters. For example, if I go with the same UART drivers, so I'll not be able to configure some of the other features of UART if I go with level 0 drivers. Whereas if I go with level 1 drivers, I'm able to configure some other peripherals also, some other things, parameters also in that cases, okay, right? So polled IOs, blocking function calls, all these things will be a part of the characteristics available here in our level 0 drivers. Whereas level 1, right, it will be a little of higher drivers, okay, right, and it will have all the information like what I've discussed in the characteristics in the previous characteristics over there, okay, and it supports configuration parameters. Multiple instances of devices can be used with that one. Polled and interrupt driven IOs can be utilized over there, okay, and generally when you go with level 1 drivers, the footprint, the memory footprint, what we got is why is it memory footprint? What is this memory footprint? Anybody? How many of you work with microcontrollers? How many of you have worked with microcontrollers? Yes.
Laboratory purpose.
Yeah. What you have done there?
8086 and 8086.
Okay. What you have done there? You have written all your instructions in assembly language. Am I right, Lokatna?
Yes, sir.
Right. If you are going with some sort of microcontrollers, we will write in assembly language, or we will write in C or C++ language?
Assembly language.
No, assembly language, if it is an 8-bit processor, it's fine. Okay. If it is a 16-bit processor, a 32-bit processor, then whatever the instruction sets required, will you be able to remember all the instruction sets?
No, sir, it is difficult.
It is difficult. So for that purpose, what most of the people will do is they will go for a higher level of languages. It is either C or C++ languages, so that at least they can write because that they will be knowing about C or C++ coding styles, and they'll be writing it. Okay.
Okay, sir.
Am I clear?
Yes, sir.
Right. So when we write this kind of codings, right? So once your coding is compiled and it is created with some sort of hex files to load it onto the controllers or processors what you are using it, right? So that will be using some of the memories. It'll take some memory. It'll take some of the what you call it as sizes. Okay, the execution file will be of different sizes based on your how much code is available and all these things. Okay, right? So that we call it as a memory footprint. Am I clear?
Yes, sir.
Right. So that's why
Sir,
we are
can you
very
please
important. So when I compile the C source code or C++ source code for the particular processor, it is going to create some of the it's going to create the hex file or an application file format what it is supported. Okay, so that file will be residing on a memory inside your processor or something, right? We call it as a program memory or something. From where it starts executing generally. Okay, so that should be always a very less size. The size of that we call it as memory footprint. Am I clear?
Yes, sir, but your voice is coming like breaking.
Is it so, Prince?
Yes, sir.
Is my voice breaking?
No, sir. Voice is fine, sir.
Lokagna, please check yourself. Okay.
Okay, sir.
Right. So that is we call it as a footprint for us. Okay, right. So it will be having little bit of higher footprint compared to the level 1, level 0 drivers. Okay, right. So it will have a lot of buffer interfaces for data transfers compared to the previous communications in the level 0 drivers. Okay, right. So if you have a example, if you want to take it out level 1 and level 0 drivers. Okay, so generally in send byte of this function, UART PS send byte function is there, right? If you can see here, UART PS.c file. Okay. So this is tab handler, this is send buffer, receive buffer, configuration initializations. Let's see, you can see here your PS send. This is one function available here for us. Okay. The same way I'll be having multiple other things also. Okay. Configuration initialize, PS send, receive, set baud rate, all these things will be our level 1 drivers. Okay. Am I clear? Yes. This is your level 1 drivers. Any questions are there? Any questions till now? At least you can say yes or no in chat box at least. Okay. Right. So this is some examples available. Okay. So this I can set it with the help of driver settings here. Okay. In this, I can open up this platform. This is standalone port support packages. Okay. So which drivers I want to use it for my peripherals, it will be showing to you here. Okay. Am I clear? Yes.
Yes, sir.
Okay. Right. Okay. I'll move further. Right. So if you want to change this driver settings, there is an option here also for you. I can go to the libraries. I can go to the modify the BSP settings. In that, I'll be able to see standalone drivers, PS Cortex NN. Okay, and this is my drivers what we have selected, and I can choose accordingly. I can choose it accordingly. I can change it accordingly for this. Okay, am I clear? Am I clear or not? At least.
Yes, sir.
Right. So let's quickly do a small exercise on creating an application project. See, this presentation will not hold good until unless if I show you what is happening there. Okay. If I just keep on presenting something, it will not work out. So I have to do an changing of windows from the the application project what I have created on the workspace what I have created for the VTS environment and present you. That's the reason I was showing you parallelly these things. Am I clear? Right. So let's go with our existing things. Okay. So now I have created the platform project. The first thing is what I required to do now. I have to create the application project for this. Okay. So for this application project to create, I need to go to File. Can I go ahead, or you want some time to have some questions and answers?
Yes, sir, you can go ahead.
Okay, right. So I'll go with create new application project. I can say next for this. Right. So this will show you the platform project, what we have created from the hardware definition file, what we have used it here. Okay. I can say next for this. And what is the application project name you want to give? Okay. I want to give the project name as lab 4. Say next. And I'm running it on Cortex NN0. Okay. Right. You want to see the processors, different processors? Yes, you can just enable this tick mark here. It will show you Cortex NN0, 1, SMP, symmetrical multiprocessing. I can show it accordingly for it. Okay, I'm going to use it in Cortex NN0. I'll say next for this. Next for this. The domain I'm going to create it standalone domain. Okay, and I'm going to see empty application. Don't go for empty application C++. It will be empty application C. Okay, if you have C++ code, you can go with empty application C++. Am I clear? Right? I can say finish. Till yesterday, you have done just completely using the templates. You have done it. Okay. So today you're going to start with completely on your own customized code here. Okay. Right. You want to create a file. You can create a new C code. Okay. I'll make it as lab4.c. Okay. In the source folder, I can say finish. Okay. And I need to start writing the code now. So what is the first things you should do it? What are the things required for me?
Include the record. Like standard.
Include what? What standard I would attach? Okay.
Reference.
Okay. Then right. So stdio.h is by default it will be included, but for me as an embedded engineer, I should start with include very first information file required for me is xparameters.h file. Okay, this fellow will inform me very properly what are my tools, what are my peripherals included in my design that I should write it. Okay, and hash include xgpio.h. This is my header file for a GPIO peripheral. Okay, which I'm going to use in my design. Okay, that I'm going to use it. Okay, and then I should start int main void. Okay, you want to start the file from here. Okay, right. So my xgpio drivers, no, it will be like this. Lib source GPIO. Okay, so they'll be having this xgpio.h file will be there in this. So this header file I want to include in my design files. Okay, and how is it declaration is done? xgpio.h, I'll include this. This is file. Okay, and my xgpio. Okay, I think my screen got disrupted now, right? Is my screen visible now?
Yes, sir.
Yes, sir.
In the middle, it got disconnected, right?
Yes, sir.
Okay, so that's fine. I from where it got disrupted, anything like that way. So I have this xgpio which I've defined it. Okay.
So while you are showing that header file got disappeared.
Okay. So this is my xgpio.h. Okay, and I have defined the structure of xgpio, capital X, capital G, small p io. Okay, and I'm going to utilize that in my code xgpio. Okay, of type, and what are the parameters you want to define? Int dip underscore push. Okay, I have two things involved in this. Okay, if you remember the block design very properly, okay, I have one switches and one push buttons and one LED of IP what I have created. Okay, this switch is my dip switch I'm going to use. Push buttons is what I'm going to use it as push in my code. Okay, semicolon. Okay, right, and then I am going to define int I comma psb underscore check. Okay, comma dip underscore check. Okay, right. So I'm going to use some print statement. Sorry, xil underscore printf. Okay, in our printf also you can use it. There's no problem. But xil underscore printf will take less number of memory resources. Okay, am I clear? Right. Start of the program. Just want to keep you very clear information about this. Okay, /r/n. What is this /r and /n is?
For next line printing.
Next line printing. That's correct, ma. Okay, right. So now I wanted one important thing in this is, so I have my design, right? And in my design, I have push buttons and I have this two things have been defined here, buttons and switches. what I wanted to do is I want this fellow to give the information to the processor, and this also to give the information. This is my external buttons and switches are available on this, and whatever the contents are read through this, right? So what is the value of that I wanted to print on my terminal? That's what is my program will be doing it. Okay, right? So now this fellow, how can I write the C code for this now? If you are writing a Verilog code, it's very simple. I'll write define 2-bit input and 4-bit input. Am I clear or not? Do you agree with me? At least you can say yes or no.
Yes, sir.
Right, in my Verilog code, I can just, what I can do is I can add this Verilog module. I'll define it, and I'll define two inputs. One is of 2 bits and another one is of 4 bits, right? And straight away write the code saying that, okay, always at the rate of something, whatever the data is read on these buttons, put it on somewhere else. I can do it in hardware. But now it is going to a AXI. It's going to AXI. How will you write the code? How will you write it? Right. So one quick thing I just wanted to explain to you, all of you, is, see, there are certain header files already available here, right? So there is XGPIO initializations is there, configuration initializations are there, okay, and set, lot of header files are included in this, okay, and there is one C code also available for you, okay. So using that, very important thing is I'll be able to understand, okay, what are the things available for me. See, XGPIO configuration initialize, this is also available, okay, and there will be some sort of self-test.c will be there. Okay, so this self-test.c is very essential for us. So this will make our job very, 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 very easily. Okay, see, I can see here, I can start with the XGPIO discrete read. Okay, and then instance pointer one, it is calling up there, and it is starting working over there. Okay, right? So this is the read. Okay, so for that read function, it is going to include all these functions very effectively. Okay, so for that to do that work, first I should initialize it. Okay, first I should initialize it and do whether it is an input or output. I should define it very properly in my C code. Okay, am I clear? Am I clear or not? Should talk out. Okay. Okay, right. So if you are not talking, I take the silence as the answer and I'll move further. Okay, right. So I should initialize this. Initialize. Okay. And dip. Okay. This is what I'm defining it. Okay. And what is my parameters? How will I know that which is my dip switches, which is my this one? I can get it from the experimenters.h file here. Okay. So this is my experimenters.h file. Okay. And there will be a lot of peripherals included in this, but I need to know, I need to use the switches. Okay, right? So this is my switch XPAR switches device ID. I'll use that in my code here. Okay, am I clear?
Yes, sir.
Okay, I will make XGPIO again. Okay, and set the data direction. Okay, yes. Is there anybody talking, asking questions, or excuse me? Is anybody asking questions, or they're talking on a phone or something? Right. So I will set the direction. Okay. So I defined my dip and push, right? So I'm going to use the ampersand of that dip. Okay. One is generally for my out input of that whatever we define it. Okay. 0x f f f f f f f f 8 times f f f. Okay. Right. In the same way, I should define it for xgpio initialize. Okay. Just copy these two files so that it will be easy for you to paste it here. And change this xbar and dip to push. Okay. And even this fellow also to push. Right. And my switches device ID is there, right? So for that, I should make it to buttons. Okay. That is why I'm asking you to give the names for that GPIO blocks, whatever created, so that it will be helpful to you to analyze it very properly. So which is for what is for where you are doing it. Okay. So based on that, it will be choosing. Right. Right. So I'll put a while loop. Right. So I'll use this PSB underscore check is there, right? PSB underscore check. I define it as an integer. Okay. Is equal to x GPIO underscore discrete read. Okay. So this I have defined it in one of the very important parameters in this. Okay. There is something called as xgpio self-test.c is there, right? So in that, I'll be having this discrete read function. I can read that very effectively. I can copy this function and paste it in my location. Okay. Discrete read and push, comma 1. Okay. And you want to print some values, zil printf, I can use it. Zil printf. Okay. And make it as push button status. Push button status. And what type you want to make it out, right? So I want to make it as hexadecimal. I'll put it as %x / r / n. Okay. Put the comma and what is the value? PSB underscore check. Whatever the value I'm getting it for the integer of PSB underscore check, I'm going to print it as in a hexadecimal format here. Okay. Am I clear, guys? Any doubts to me till now? Right. In the same way, I want to put it as dip check also. DIP underscore check. Okay, which I have defined it, and discrete read and push. Okay, instead of push, I'll put it as dip, and this I'll put it as DIP check. Okay. And close the while loop and save it. Am I clear? Any doubts to me?
Therefore, dip also the printing statement should be push button status.
No, ma. Dip I've taken it. I've taken dip check for dip switches and push for push buttons. Okay.
Yes, therefore, in the printing statement, you have given push button status.
Okay. That if you sorry, I missed out. It's my mistake. Dip switches. Okay. I'm sorry. It's my mistake. Okay. Right. Now I want to do one small thing in this. I have this LED also, right? I have this LEDs also. This LED IP what I have created, right? So for this LED IP, I wanted to write a driver code for this one. So from where I can get it? I can get it from the LED IP SRC file here. Okay. So for that, I have to include my LED IP.h. Right. I have to include this LED IP.h file. Okay. This header file should be included. LDIP.h header file should be included. Okay. And see, it is an custom IP, so not required for us to do any initializations and all those things. Okay. Whereas in our standard driver files, this initializations and set data directions is required. Okay. Am I clear? Am I clear or not?
Yes.
Right. So in this, there is something called as LDIP mWrite registered is there. I'll use this function. I'll use that function. LDIP mWrite registers, and my parameters for that will be available in my experimenters.h file. Okay. This is my device ID for this. Okay. Or you can select the AXI base address also. Okay. Because this fellow will take the base address, not the device ID. This function. Can you see this? Yes. Right. So I'm going to take the function export LED, whatever I defined it. Okay. Comma 0, comma, what value you want to put it? I want to put PSB underscore check. Okay. So this PSB underscore check is my push buttons check is there, right? So whenever I'm going to press some push buttons, the LED should blink for me. Okay. Right. So there is an error here. Missing semicolon is showing. Okay. And put it. Right. So you can put a for loop if you want some 99,000 something time. Sometimes you want to execute it or you want to keep it as it is. It's up to you. Okay. I can put that for loop also if it is there. For I equals 0, I less than 8 times. Okay. Okay. Less than. Okay. I plus plus. Right. I can save this. And once you are written, I can just build this project. Okay. There is something. Okay, undefined reference to zil printf. Okay, why it is coming?
The 9 should be 8 times or 7 times.
Come again?
The 9, which is I less than 9.
Seven times.
How many?
7 times. 7 times I written it.
Okay.
My question is why is giving me error for zil printf. Why?
The header file, which include the function, is not included.
What is that header file?
Again, sir.
Huh? Yesterday you have seen the Hello World program? Yes.
No, sir. Yesterday I didn't attend the class because I have some academic studies.
It's a very bad thing here.
All the recordings I want to see tomorrow or after this class.
See, one thing is recordings we can provide you. If you have some doubts, then what you will do?
Yes, sir. But I need to go to the college, sir.
Okay, I'm asking to some other people who have attended the class.
Excel types.h.
Can you repeat it, please?
Excel types.h.
I'm sorry, I couldn't understand your pronunciation. Can you just make it out?
Excel_types.h.
Exile_types.h. Okay, then
xwortps.h.
right. Hash include stdio.h. Okay, this is one thing. And you said hash include platform.h. stdio.h is our code. And you told zil types, huh? What is it? Hash include.
Yes,
What is
sir.
that,
Zil
ma?
types. Zil types.
Exile_types.h. Huh? Still, it is giving problem. Zil printf.
Sir, hash include xwortps.h is also included yesterday.
What is that?
Capital X, capital V, artps.h.
Not required. Actually, there is no capital X. It is small x. That's a mistake I did. Okay. So stdio.h is not required. This still printf.h also is not required. If you want, you can remove this. Okay. There was a small simple mistakes I have done it. It is capital XIL I put it. That's the thing. Okay. Am I clear? Yes.
Yes, sir. If there is any document related, what are the functions are there?
Come again.
If there is any documents related, how
There are
to
a lot of software development documentations available in the Xilinx website. It's around 1,500 pages or something. So it's no shortcutted method for that one. You can go and have a look on that. Okay.
Okay.
Right. So I've done this one. Now I have to switch on the board. Okay. And open the Terraterm. Open the Terraterm. Okay. So this tool is freely available. You can download it and you can keep it. Okay. Serial. And the baud rate which we are using, it is 115200 by default. Okay. How can I change this baud rate? How can I change it? Baud rate. Here I can go to this zinc processing system block diagram is there, right? Here. I can go to PSPL configurations, general UART1 baud rate is, this fellow I can change it. Okay. But if you change it here, then again I have to regenerate the bit stream. Okay. Am I clear? Right. So let me just run this code. Right click on this, say run as, launch on hardware. Okay. I don't know whether I can just. One minute. Just give me 2 minutes of time. Just give me 2 minutes of time. Okay. Already my program is running here. Don't worry. Okay. Join the meeting. Okay. Right. Sorry, 1 minute. Be online. I'm trying to change the camera. Okay. Okay. Can you see the board now? Can you see the board? Yes or no, at least?
Sir.
I have. It's there. It's showing to me the chat box. You can just pinpoint that board. Okay. So this is my dip switch status. If I make this dip switch change, so you can see the output on the terminal there as dip switch status 3. Okay. 2, 0, 1, Can you see it?
No, sir. You're unable to see that board.
Elias, you have to in the meeting. No, there is Prakash will be displayed there, not the screen. Don't see the screen there. On the screen, it will not be visible. Not on the shared screen, it will be visible. If you come to the main window.
Yes, sir. Yes, sir. Got it.
Okay, right. See, when I press this push buttons, the LED will get blinking. Okay. So why it is blinking reverse way is because I have made a small mistake there. I have connected the LSB of my LED to the MSB of my push buttons. That's how it is in the hardware. Okay. Am I clear? Yes. And you can see that the dip switch push button status also changes when I'm pressing this button. You can see there is 8, 2, 1, like that way it is coming for us. Can you see? Yeah. I hope it's clear to all of you. Yes or no? Yeah. Any questions are there? Right. So if you want to do a debugging, so what is debugging in software? What is debugging in software? Just to all of my friends who are sitting here. So when you are working with software applications, right? So I want to do debugging like single step execution. I want to see the memory contents. I want to see the register contents. All these things I want to see it. Yes or no? Yes, sir. Yes. At least say yes or no for that, right?
Yes, sir.
Yes, sir.
Right. Okay. So I can do that debugging with the help of this same window only. Okay. So what I can do is I can just stop the project. Okay. I'll switch off the board. Okay. I'll switch on it again. Okay. And I'll clear the log file here. Okay. I'll clear it. And here I have an option to do right click on this, say debug as launch hardware. Okay. So this window will get opened automatically. Wait for a minute. Sorry, my board was off. I'm very sorry for that. I'll right click on this, say debug as launch and hardware. Okay. Right. So it will come and stop at this point. Zil printf status is this one. Okay. I want to set some of the breakpoints actually. So what is this breakpoint means? The compiler will come there and stop the execution at that particular point of time. Okay. Am I clear? So you can see in the wizard also, it starts with it is waiting for this line to execute now. Zil printf this one. Okay. The same way I'll put one break statements at line number 20, line number 22, okay, right, and line number 23. Okay, if you just double click, it will add the breakpoints. Okay, am I clear or not? Am I clear, guys?
Yes, sir.
Right, so this breakpoint is getting added. Now you want to do a single step running, I can go to run, step over, I can do it, or I can go step into, it goes here and it starts executing. Right, so one by one I can do like this. I can see the registers also in these cases. What are the registers involved? Modules included, variables included, everything. And you want to add some memory points to this, some unnecessary things you want to add. It's up to you, okay? You just want to add this, okay? Nothing, there is nothing, I don't know what is there in that memory, okay? Just want to get into that one. And it starts into executing here, okay? I can come to this run and I can say step over, it come out of like this way, okay? But again, if I go back, it will keep on running this execution. So until unless this fellow executes that whole piece of code of drivers, little bit of drivers, it will wait for that one. Am I clear? Yes. I'll relaunch it, okay, just for your information.
Sir, can you please again explain from the running step?
Okay, I will go out of this design mode, okay. Right here in this lab 4, right, debug as I'll go and I'll say launch on hardware. Right, so it is waiting for this execution here, okay. So now I can see that all my variables, what I've defined, what is the value of this, I can see in these variables, and I'll be able to see the register contents also, R0, R1, all these things, program counters, everything I can see it in this window, okay. And the same way, I'll be able to add some of the memories also included, okay. I can just click on plus mark and put the value, it will come automatically here for us, okay. Right, this is also possible. And I've set the breakpoint for this line number 20, line number 22, and line number 23. Okay. Right. And if I go here and say run step into, it will come automatically to come out of this and it will run. Right. So step 4, if I make it, it will come out of this and initialize this dip switches. Okay. And you can see that the start of program started here in this. Okay. So initially I was already executed the program. So because of that, it has printed all the values as 0 before that one, because previous execution steps are still available here. Okay. Am I clear now? Right. Now I can click on resume again. Step over, I can do it. So this will make the direction. Step over. Right. Now this will initialize the buttons. Step over. So now it is adding this push buttons, read contents are going on. Okay. Right. And if I go to run, step over, it will print the values, push buttons. Okay. So what is the value we are supposed to get it here is push buttons value is still 0. Okay. So that's why it will be showing it as 0 only for us. Right. It is again going for reading the dip switches. Okay. I have made the dip switches a little bit high. Okay. And I'll go to step 4 again. and I'll print the value of dip switches. You can see here the dip switch status is 1, it is showing, whereas my push button status is showing as 0 because I have not pressed any of the values. That's the reason here. Okay. Am I clear?
Yes, sir.
Okay. Now I can run this step over again and again. And this will be in the same loop for this much time. Okay. Right? Until unless that loop gets overloaded, it will not come out. If I make this running again and again, it will come, the dip switches like this way, it will keep on running. Okay. Am I clear? Yes?
Yes, sir.
Right. So this is about debugging, software debugging, just software debugging. Okay. Now I want to do a software debugging as well as hardware debugging. How can I do it? How can I do it? How can I do it? So for hardware debugging, what we'll be using it? Yes. First day of session which you had with Mr. Sankalp, what was the concept you had been taught for the hardware debugging? Yes. Can I get the answers, please? Can I get the answers? Yeah, tell me.
Debug hub can be used for debug communication.
Lokagna, can you be clearer, ma? Your voice is a little bit feeble.
Debug hub can be used for debug configuration.
So for debugging, debug hub, what is required? Debug hub is something which is not generally available.
Debug probe files will be sending to
To get that profiles, what are the IPs we are using?
that much, no particular idea.
Lokagna, I was trying to get answers from you. Like for doing the debugging, hardware debugging, I need to use some of the IPs called as ILA and VIO and all those stuffs, right? Yes.
So,
So most of you might have heard about this IP core debugging. Like through ILA, I'll be able to do the debugging very properly. Okay. Right. So they are called as the hardware debugging IPs, which are required for us. Okay. So that I can enable it only with the help of this project files here. There are a little bit of small changes I need to do in the project here. Okay. Okay. Is everybody clear of the things what I have informed to you? Is anybody has got any questions? Right. So quickly, I'll just run through whatever Sankalp has done that day. Okay, I'll not take much time of this. Okay, here it will be. What is this? Okay, right. So we want a logic analyzer. We have got some different codes available for us. That is, we have got virtual input/output codes. We have got inserted logic analyzer codes, ILA codes, what we call it as. Okay, so those things I can instantiate in my design, and I'll be able to use the same JTAG cable to debug my signals of my design what I've created. So it can be I can do it completely on an RTL code. I can do it completely on my processor-based designs. Whether I want to do it with a hardcore processor, softcore processor, I can do it with the help of these things. Okay, right? So debugging will be nearly around like it will be working with the same frequency at what design is working out, because I'm going to use the same clock there. Okay, right? And I'll be able to see the debugging with the help of the logic analyzer, which is a part of the Vivado tools which we have installed it. Okay, so no need for me to go for external logic analyzer. If I go with external logic analyzer, then I should again bring out all my pins that to IO ports and define them and connect them with a logical probe available there. Am I clear? Yes. Right. So there are ILA codes available. Okay. This I've already Sankalp has explained to you in the first days. I'm just reiterating these processes. Okay. Right. So this is system ILA code which we want to use it for our IP-based designs. Okay, I'll be using that one. I can select it. Okay, so this is possible with the help of this here in these cases. I can right click on this and make a debug probe. I can make it like this, and I can select this buttons. I can right click on this and say make debug. I can do it. Okay, am I clear? Any doubts to me? Yes. Any questions are there? Any questions are there? Okay, I take the silence as the answer. No problem. Okay. I will just delete this board. Okay. And okay, keep it as it is. No problem. Okay. And even I wanted to add this debugging ports. Okay. Debug. Okay. So I got 3 different debug ports. You can see a small symbol on this, like a spider. Is it visible? Yes.
Yes, sir.
It's visible. Okay. Right. So I am going to make one small changes in my processing system. Okay. I'll go to this PS to PL configurations. There's something called as PSPL cross trigger interface. I'll enable this. Okay. So there's an input cross trigger and output cross trigger, what we have required for us. Right. So there is a cross trigger input 0, CPU 0 debug request. See, I'm very much telling you one more time. If I am going with only one processor, I can use only one CPU debug and acknowledgement, request and acknowledgement. Okay. So if you're going with multiple processors, it is your responsibility to give the acknowledgement and other things. Okay. Am I clear, guys? Right. Say okay for this. Don't worry about other things. Okay. Right. You want to do debug on this separately? It's up to you. Okay. This will just show you the complete LED ports definitions here required for us. Yes, any questions are there? Right, I'll just make the run connection automation. Right, so this is ILA, I'm going to use it. Okay. So now I want to add debugging for this probes. I want to see the AXI signals coming here. Okay, right? So for that, I need to add one more very important step, that is system ILA. Okay, I'll use that one. It's going to automatically come this into this ILA system ILA IP is included in this. Okay, and this fellow, now this has to go to the system ILA. This has to go to the system ILA. Right, this is completely different. The trigger in of this has to go to the trigger out of my system ILA, and the trigger in of this has to go to the trigger out of my processing system. This is what is required. And I have included an ILA probe for this to see the output of this. Okay, and I can validate the design first. Okay. Right. So there is a hardware change now. So obviously I have to rebuild the whole project. Okay. So keep it in mind, my dear friends. Whenever you are changing anything in the hardware definitions, you have to do synthesis, you have to do implementation, you have to do generate bitstream, and then you can proceed further automatically for all the aspects. Okay. So before doing that, you make sure that your wrapper is again created. Create the wrapper. And generate the bitstream. Okay. So any questions are there? Right. We will just break for 5-10 minutes. By the time it can complete, no problem. 15 minutes you can break because it will take some time. Any questions are there?
No, sir, no questions in the chat box.
Prince, I think the chat box I'm able to see it. If somebody is asking some questions.
There are no questions, only they are saying about the PPT and the
Yeah, nothing is there.
Okay, right. It's up. Not an issue. Right. Okay, that's fine. We'll just break for some time.
Yeah,
For
sure, sir.
at least for 10 minutes, we'll break it. Okay. So it's 3
Yeah,
o'clock
sure, sir.
now. We'll arrange come back at around 4 o'clock.
Yeah,
Okay.
sure, sir.
Sure. Chipping team, there are very less number of participants joined here. Just call them up or at least message them in the group somewhere. At least they can join it.
Yeah, sure, sir.
Okay.
I think there are right now eight participants are there. I think their team members may not have joined because each team has 5 members. So I request them to just ask your team members if they have not joined, please ask them to join.
Sure. Okay. Right.
Yes.
Right. So one more thing is this: ask all of your team members to fill out that feedback from which we are sharing it in the chat box. Okay.
Okay,
I
sir.
already shared. I already shared in the chat box. Okay. You can fill out that feedback from. Okay. Okay then. By the time it completes, I will have a break and we'll come back at around 4 o'clock. Okay. So once this is completed, we are done with the whole sessions completely. One small thing I'll just show you to you is that how to do the installations of the software. Okay. And system environment variables. Prince, are you aware of the IP address to which they can make the pointing for the server?
No, sir, I'm not aware of that.
Okay. I think
What you
Pranos
want,
was
sir,
aware of.
exactly?
Just check with Pronos this regarding the license manager so that at least we can point to that IP address and what is the port number required for them and they can use it for the working procedures.
Okay. Is it required today?
Not today, but they can do it afterwards. Not a problem. But I'll
Oh,
show them
okay,
the
okay, okay.
process.
Okay,
I'll
okay,
show
okay.
them the process. Not a problem.
Okay, okay. So I will convey, sir.
Sure, no problem. I'll just mute myself now. Okay.
Yeah, sir.
We'll be back around 4 o'clock.
Yeah, sure.
Sure. Hi, can you start? Hello, can you hear my voice? Hello. Hello. Can you hear my voice? Hi, can you hear my voice or not?
Yes, sir.
Okay, I think the chip-in team has not yet joined.
Yeah, sir, my network connection is.
Yeah, I hope it's clear. Can I start the
Yes, sir.
session?
Yes, sir. Yeah, please, sir. Please start the session, sir.
Sure, sure. Okay, no problem. I have done the implementation and bitstream has been generated. Okay. I hope my screen is visible.
Yes, sir. Now it is visible, sir.
Yeah, okay. Right. I'll just cancel this. I need to export this hardware, okay, and include the bitstream. Same steps, whatever we did, we do it, right? So that's the same thing, okay. I will export it to this lab5 debug, okay. I can select this and give a file as lab6, okay. And this is what is required for me. The same C code what we have defined in the previous stages. I am going to start with that only. Okay. Right. I'll open up the Vitis Classic. Vitis Classic. Okay. So it will ask you for the workspace. I will go for that workspace. Okay. Where I have created. So you should be aware of where your project is located, and all these steps is very essential for us. Okay. Right. So I'll create a platform project first. Same steps, whatever I created earlier. Okay. Lab 6 flat. Okay. So there is a changes in the hardware. That's why I'm creating the platform project from the first step only. Okay. And I will browse that XSA file, what I have created, exported it from Vivado. I'll say finish. Right, so I'll build the project. It's it is running now. It's going to create the platform project output file, that is a libzil.a, what we call it as. Okay. So once it is created, it will be showing to you here. Okay. So this is all the .d file, .o file, everything will be included in this. Okay. Right. So once we have created this, I need to create the application project. Say next. Make sure that platform project what you have included has depicted to you. Okay. Right. So lab 6 app, I'll put it as. Okay. I can say next. Next. Right. So I'll select the empty application C. Right. Finish. I'll create a new file, lab6.c file. Okay. Just use the same parameters. Okay. Right. I will save this and include the breakpoints wherever you want to have it. Okay. And build the project. Now, so now I will go to right click on this and say debug is there, right? So there is a debug configurations available here. Just wanted to add that files. Okay. Single application debug, you can double click on this. Okay. Then the applications, target setup. So this enable this cross triggering. This is required. Okay. So if I don't enable this cross triggering, then the ILF files will not be able to do the tasks. Am I clear? Any doubts? I'll create this CPU 0 debug acknowledgement, and if I can have CPU 0 debug request, and this FTMs trigger points, if you want to add it, that's also required. Okay. Right. One is CPU 0, I have made it, and in this cross trigger output, I have taken this FTM signals. In the same way, I have to create one more CPU 0 debug request and FTMs. Both the triggers I need to make it out. Am I clear? Any doubts to me? Say okay again. Right. You can apply and close it. Okay. And then I have to rebuild the project. Okay. Am I clear? Any doubts to me? So I can use this term also, or there is one option called show view. Okay. There is a serial terminal available in this Vitis terminal also. I can double click on this and I can add that block. COM4 and the baud rate is 115,200. Okay, I can use this or that, no problem. Anything is fine. Okay, I can say debug as launcher 100. You can go to the debug again, okay, and say debug. This is programming the FPGA. Okay, so it has come here and it has stopped at this point. Okay, right. So I'll go to the Vivado project here. I'll open the hardware manager. Okay. And I'll open this target. I have multiple debugs included. Okay, it's not be required to include everything. Just for your understanding purpose, I have showcased that to you. Okay, anyone is fine for us to understand the read address channels, read write channels, what is happening there. That's one thing is always keeping in mind. Right. So we have this M01, M02, and M03. So what is this M01, M02, and M03? What is this? What is that? See this fellow M01 is connected to the buttons, okay, and M02 is connected to the LEDs, and M03 is connected to the switches. Okay, am I clear? Buttons, okay, M02 LEDs and M03 switches. Okay, just wanted to make sure that you have understood everything. Okay, I'll open the target again. Right, I want to rename it. So slot 0 M01 is for buttons, okay, and my slot 1 M02 is for LEDs. I can rename like this, okay, and this fellow is for my switches. Okay, if I click on trigger, it will not come anything. Okay, it will show as the 0 because still the program is not yet started. Okay, right. You can see here there are a lot of signals included with AR, write channels, read channels, AR channel, read channel, EW, write channel, B channel, response, all these things will come into picture. Okay. Is it clear? Any doubts to me? Any doubts? Right. So now if I come here, it started the programming. Okay. I'll go to run, step over, and it will print the terminals here. It will print the values of, I'm sorry. Oh, shit, I did a mistake. Just 2 minutes. Okay. Okay, so it is here. Okay. So now I got this start of the program printed in this case. Okay. Now if I run again, step over. Now I got my dip switches running here. Right. Initialize the push buttons also. Okay. I have come and stopped here at this point. I'll go to the Vivado project and I will try to trigger it again. Okay. Can you see there are some movements happening in this? Can you see it? Okay. Can you see it or not?
Yes,
Right. Okay. I will run again. Right. I'll check the values of the push buttons and it will be printed here. Okay. Right. I have pushed some of the buttons. Okay. Let me run it again. Right. I have put push button status is showing it as 8 because I have pressed the MSB of the push buttons here. Okay. Now let me see in the Vivado what is happening. Right. Okay. Valid signal is coming or not, ready is coming or not, I can see it very properly. Okay. Am I clear? Any doubts to me? Let me run the next statement. Step over. Step over. Then the PSP check. Okay. I didn't include this. Okay, it is there. Right. Now, when I run this continuously, it should print the value of the PSP check on my board, okay, and on my hardware design also. Right. Can you see I'm getting the value as 8? Yes. Can you see it or not? Can you see it or not? At least say yes or no.
yes, sir.
Right. So I'm able to see the signals very effectively in this. That's the advantage I wanted to show to you. Right. I am able to debug lot of things, signals in this, and understand very properly all the signals. Am I clear? Yes. Am I clear or not?
Yes, sir.
You want to put any of the probes in this, you can put a probe. I can see that. Capture setup. You can make it like this way also. You want to put some values for this R data. And trigger it. I can see them. Whether it's properly done or not, it's going on. It's waiting for trigger to happen here. Okay. Okay. Right. Able to see a lot of whether it's ready or not. Like that way, I can see the signals here. Okay. Any questions to me till now? This is just for your understanding purpose. Okay. Any questions are there? Any questions are there? I'm just joining in from some other machines. Okay.
Okay, sir. Okay, sir.
Can you hear my voice?
Yes, sir.
Okay. Just give me 2 minutes. I am just joining two other devices. Okay. Can you hear my voice now?
Yes.
Okay. So quickly, I'll just run through the installation steps. Okay. Can you see my screen?
Yes, sir.
Yes, sir. Screen is visible, sir.
Okay, right. No problem. Okay. Right. So whether you go with 22, 23, whatever is required, no problem. Okay. So don't worry about these versions here, right? So first step we should do always when you if you're installing in Windows, just double click on this X setup. Okay. So just it will be an X setup file like this way. Just double click on this, it will open up this wizard like this way. Okay. And if you're going with Linux, make sure you are installing with root permissions. So that's why I have taken this sudo /xsetup file. Okay. And once we start with this, automatically it will open up the wizard like this. So preferences you can go. Okay. So in the preferences, make sure that core or CPU settings set it as maximum. Otherwise, when I'm doing a synthesis, right, the number of jobs will not show to the maximum portion whatever is required. Okay, right? And disk usage settings, you disable this. You can note down the steps. Right? So this I can say okay and say next for this. Make sure you select only Vitis. Don't select only Vivado. Okay, if you install Vitis, automatically it gets installed the Vivado software also. So keep it in mind. Am I clear? Am I clear or not?
Yes, sir.
Okay, so select that next. So here you might be not required to, if you don't want to use some of the devices, you can just disable them. Okay, or you want to enable everything, it's up to you. Okay, then the space will be a big challenge for us. So that's the reason I'm trying to at least see the disk space required for to install it is around 201.85 GB. Okay, say next and agree this. These steps are very essential. Okay. Agree to choose all these parameters. Okay, say next and then install. Okay, already I have installed the tools, that's why it is showing me in the red color. Otherwise it will show it as some other files also. Right, it will be by default, it will be in /tools/Xilinx if you are installing it from root. Okay, otherwise this portion is it's your responsibility to give the space utilization and all. Right, once you give that, it will give you next option and then afterwards finish the installations. Okay, so once your installation is done, okay, the very important step is, see, in Windows I can set the environment variables using two factors. One is lm_license_file. These two files are required for us. Okay, so these two things, lm_license_file. Okay, and it should be set to 2100 at the rate of the IP address what the chipping team will provide to you. Okay, the IP address, and there will be one more variables called Xilinx XD underscore license underscore file, right? And it should be also pointed to 2100 at the rate of IP address. Okay. Am I clear? Any doubts to me till now? So in Linux, you have to set this path using the bash rc file, okay? Or you can set it through like this. Right? So in Linux, I have to do it with the help of two commands: export lm underscore license underscore file equals 2100 at the rate of IP address of the server. That's one thing. Okay. And one more is Xilinx XD underscore license underscore file is equal to 2100 at the rate of IP address. Okay. So make sure that this port is enabled in your laptop. Okay. And one more very important thing is the firewall should be off so that at least you can fetch the license very effectively. Okay. That's one thing, right? So once you fetch that licenses very properly, then afterwards you will be able to see the license parameters like this. Right. So it will show you whether required, what are the things required here, and it will show this paths here also. Okay. Am I clear? Any doubts to me? If anybody has got any doubts, let me know. Okay. Any questions are there? Anybody has got any questions?
Yes,
And if you have any questions regarding day 1, day 2, and today's sessions also, let me know. I will be able to help you out. Any questions?
Sir, there is no more questions in the chat box.
Okay.
Yeah, participants, you can ask questions. You can unmute yourself and you can ask questions. And regarding IP and the port, sir, I already conveyed. It will be shared with all the participants before the hackathon, sir.
Sure, sure. That's fine. That's fine. Thank you very much, Chipping team.
Yeah, sure, sir.
Excuse me, sir.
Yeah, tell me.
Sir, actually, we were asked to bring our laptops for the hackathon process.
Yeah,
Okay.
yeah. You have to bring laptop with charger. Yeah, that
Sir,
is.
is it necessary to download all this in our laptop, sir? Actually, we are accessing in our institute laboratory system.
For hackathon, you need to install actually. How will you do here? How will you do it here when you come here?
Like our SPOC said that we will be assigned a system, sir.
Who? SPOC?
Told that we will be assigned a system for hackathon process.
Who told you?
My team lead informed me, sir.
Okay, just please confirm once, sir.
Okay, sir.
Because we have mentioned in the guidelines that you have to bring your laptop with charger. It should be in the working condition.
Yes, sir. But it is not mentioned that whether to install or not. That is why I'm asking.
No, it is better if you install. I think otherwise you will install there and you will waste time.
Yes, sir. Okay, sir.
Okay, any
Thank
other questions from the participants?
Sir, this is Ajit. Actually, some of our teammates have Macs, so we do have three Windows laptops. Is it okay to work with three Windows laptops?
You do one thing. You have assigned a point of contact, right?
Yeah.
You can have like conversation with them. They will guide you properly.
But is it necessary to have all guys installed with Vivado?
Actually, I am not the right person to answer this question because whatever point of contact persons are there, they will answer
Okay.
your queries. Yeah.
1 second, Prince. Let me just
Yes, sir.
try it out. Ajit, see, one thing is if you install the tools, there's no problem in harm in using the tools over there, right? It will be
Like
helpful to you to have lot of if some people are working on some other modules and you can work on some other modules. That can be a quality work with you.
Yes, sir,
You
but
can install later on. You can uninstall.
That's fine, sir. We would be using in our academics as well, but we do have only three Windows laptops and only three Vivado to parallelly work in. So, is it okay, right? Like, or else all the
That's
5 students should have and should work parallelly. Is it not the case, right?
you can. Ajit, you
Okay.
can do one thing. You can put the questions in the chats there. Already there are a lot of people who are involved there, right? So you can put that question
Okay.
there. Okay.
Yeah, you could just put the question and concerned person will answer your query. No problem.
Okay, okay. Yeah,
Yeah.
thanks. And
Yeah.
regarding installation, like I have checked the Vivado during the
Mhm.
installation, and it has also downloaded the VTs with Vivado.
Okay. Okay.
So that's fine. That's fine, or else I need to again install VTs separately.
See, that's what Ajit I was trying when I was showing you that window. If you select Vitis, it will install Vivado also.
Okay, but I have chosen Vivado
But there is
at
no,
first.
but that's what, there is no option to install Vitis separately.
Okay. But during
Either you
installation of
uninstall this word,
okay.
that's what I'm trying to tell you, Ajit. So
Mm.
if you can uninstall this Vivado version and
Mm.
reinstall this Vitis, it will include the new versions also, the same versions also of Vivado.
Yes, sir. Like there's also another option like we can download necessary VTs files even after the installation of Vivado. Uh, is it also
But
fine?
that takes offline. That takes an online session, online thing. It will not work with downloaded files.
Okay.
It will take internet for you,
Okay. Okay. Yes, sir. Thank you. That's it.
and it will download. It will download that, and again it will start working. So it takes double times,
Mm-hmm.
and it will be overrated. Means one, if you have installed it in C drive Xilinx, so there will be two versions of Vivado installed there,
Okay.
and it gets conflicted.
Yes, sir. Yes, sir. That's fine. Thank you.
Yeah, yeah.
Sir, in which platform it is better to install, sir, whether Windows or Ubuntu?
See, it's up to you, Mama. There is no such thing that you should have only in Windows, you should have in Linux. Then it becomes very cumbersome answers from my end. Okay. So if you're finally okay with working with Linux, you can install in Linux. But if you're not comfortable in working with Linux, better to go with Windows.
Yes.
Okay. Because in Linux, there are a lot of scripting and command line languages to be used to be required. And cable drivers will not get automatically installed, and we have to reinstall the cable drivers. Then the packages required for that has to be installed. So it takes multiple times work of this. That's it. Okay.
Yes.
Yeah. Any other questions? Any other questions?
I think, sir, there are no more questions from the participant side.
Okay, but I need that feedback form to be filled by all the
Yeah,
participants. Okay.
yeah. Please,
Right, so
I request all participants to fill that feedback form so that it will give us the feedback about today's session.
I kept 15 minutes for the question and answers, because keeping in mind that it will be helpful to understand a lot of things. That's the reason I just kept it for multiple things here in this. Any questions are there? Any questions are there? Any other questions are there? If there are no more questions, I think I can wind up the sessions, Chipin team.
Yes, sir, there are no more questions in the chat box, and also participants have no more questions, further questions. So I think we can conclude this session. So
No problem. That's
thank you all participants for your active participations, and I hope you must have learned from day 1 to day 3 about AMD Xilinx full flow, digital design flow, and hope it will be beneficial in upcoming digital design hackathon, and it will be fruitful to all of you. And if you have still any doubts and any queries, you can reach out to us. There is a WhatsApp group in which you can ask your queries. Sir is also added in that WhatsApp group, so feel free to ask your questions. We will resolve as soon as possible. regarding the tool installation and the sessions day 1, day 2, day 3, whatever doubts if you have. So and at the end, sir, I really thank Coral team for accepting our invitation for conducting this pre-webinar before the hackathon. So thank you, Coral team. Thank you, Prakash sir, and thank you, Coral team, once again for conducting these sessions. Thank you, sir.
Thank you, Chipin team. It's very pleasure to work with all of you. Okay, and the participants have a great day and welcome to the hackathon. And it'll be very good thing that you have started working with that FPGA boards. It's very important for you to understand. See, these 3 days, what we have done is we have tried to give you information about like how these boards can be utilized and how the code can be written on the Vivado software and how to do the simulation, then synthesis, implementation, then debugging of the design. And then if you have a processor based designs, how can I use that processor based designs, how to use the IPs in my design in the Vivado IP integrator, these things. And outright after that, once your hardware is generated, bitstream is generated, I how to export that to the Vitis environment and write the application code. That's and how to debug the application code and how to do and hardware software debugging, cross triggering kind of thing. This whole thing we have tried to give you in this 3 day sessions for you. Right? I hope it's fruitful to all of you, and you'll be able to. If you are not able to understand any of the points, let me know. At least I can put the effort to answer your questions wherever is required for you. Okay, right? Anything is required, you can put me the questions, and if you have any questions, you can be in touch with Chipin team. They'll be able to help you out to connect with us also. Okay.
Yeah,
And
sure.
thank you. Yeah, thank you very much for
Yeah,
all the participations. Yeah,
yeah.
yes, tell
Thank
me.
you, sir. Yeah, one question is there. Someone was asking. Yeah,
Yeah.
please go ahead.
Sir, actually, in this hackathon, the all our teammates should be participate, huh? Because one of our teammate got injured and he hospitalized now. Huh? So can he join virtually or he must come there?
Okay, you
Like
you
that.
please discuss this with. I think there is a contact number given for you to do that activities, right? So you can put a word to them because I'm not the right person to answer this question.
Yeah, you just contact your POC. He will guide you. No problem.
Okay, okay. Sir.
Yeah. Any other questions from the participants?
Okay, I think there is one question from Pashan Pranay, right? Pasham Pranay. Okay, yeah. Hi, Pasham. So the question is how, hello, sir, due to academic activities, we are not able to participate actively in these webinars. Can we watch the recording and provide the feedback later? Do you want to, like, see what happens is this feedback is what is required for us to understand whether we were able to match your expectation or not. And you are not able to attend these webinars and watch the recordings, then it's not worthy of, like, it will be like squinching for you. So always keep it in mind, because both the team members like Chipin team and we both together have struggled a lot to do activities like this, right? So uh, there is no problem. You can give me the feedback now or later, but I don't think that the feedback form will be later will be accepted. Okay, so this is very clear answer from my end. But at least you could have tried to attend these sessions, because that's the keeping in mind of student perspective. We have conducted these sessions on Friday, Saturday, and Sunday. Others I would have taken this in weekdays also. Right, Chipin team?
Yeah, sure, sir.
Right, Pranay, is it fine? Answer is fine for you? It's okay. I'm not telling that you've done the wrong thing or something like that. Here, I wanted to understand from a lot of. See, if you could not participate, your team member can be a active participation sometimes. That can be one possible solution from your end. Okay. Right. Okay, then I hope it's clear. Thank you, Chipin team, for providing the platform for us. It's a great pleasure to work with all of you. And if anything is required, let us know. I will be there for your services. Okay.
Thank you, sir. Thank you very much. Thank you so much for conducting these sessions. Thank you all participants. So now we are concluding the session. So now we are ending the session. So thank you all once again. Thank you, sir.
Thank you. Thank you. Thank you. Yeah.